by Dr. Shantipriya Parida. He is a senior AI scientist at Silo AI, Finland, and with 15 years of experience in software development, architecture, machine learning, deep learning, and natural language processing. Dr. Parida brings extensive expertise, boasting over 70 publications and 600 plus citations. So, I would like him to start the session.
Yeah, thanks, Varun. So I hope I am audible properly. Yeah, so welcome to the Generative AI and LLM workshop. So first, I'd like to thanks for all the participants who have shown interest and they have filled the registration to join the session. So quickly, I'll go through the our schedule, and later on we can go through more details. So let me share my screen. And so I hope my screen is visible. Uh, can someone confirm? Uh,
Yes, it is visible.
Yes, sir.
okay. Yeah. Thanks. Yeah. So I think all have received the updated schedule. So if somebody has not received, then you can message in the WhatsApp group. We can send it again. So this is the agenda. So we'll start like from the Odia Generative AI overview and journey. So like how we started this organization and what are the things we are doing. So that I will start from Dr. Kusumlata and Satya Ranjan. He will start with the session. Jen actually will start slowly about some generative AI and LLM overview. And subsequently, we start with our guest speaker, Dr. Raj Dabre, who will talk in advances in Indic natural language generation. And at 11:35, actually, we have a QA session. So it will be QA session will be joined uh, by Dr. Swaroop Misra and Raj Dabre. So mostly in the QA session, we are covering about the instruction tuning, prompt large language model or enterprise LLM, Indic natural language generation. Actually, due to some time schedule, Dr. Abbas, he may not join this session, but he has a subsequent session. And already I have said the form, like if you have any questions relating or queries relating to these topics, you can feel free to fill it so that we can take a few questions from that. And at 1:20 p.m., actually, we'll start from the instruction set preparation, theory and hands-on, and then we'll have a LLM fine-tuning, both the theory and hands-on. And at 2:50, we have a session on LLM model evaluation. So here we'll cover a use case about how to evaluate the model. And 3:20 p.m., actually, we have a talk from Dr. Abbas about the open conversational AI, like how the enterprise level LLMs are building. So that will be at 3:20, and at 4:05 we have a session on LLM inference and deployment, and 4:45 a session on RAG, and 5:40 LLM use case. So last session will be based on the availability of the speaker. So yeah, so this is like the overall uh, agenda. So I hope all have received this, and few more things I'll say. Actually, for the theory and the hands-on session, actually all your prerequisites, actually we have created a document which will share it soon. So mostly you need for you need your you need a OpenAI key for running the experiment and a collab account, and all the required details will share it soon. And so I request like those having already filled the queries relating to the QA session, you can fill it in the link. Uh, and yeah, so that's all from my side. And if you have any questions or anything, so feel free to ask through the chat. We have a separate communication group is there. And one more thing I'll tell, like the audience like from different background, like from B, MCA, MTech, starting from PhD. So some are from academics, some are from industry. So looking, considering all, actually we have designed in such a way the program that it can helpful for all. So we'll not go all details from each topic, but we'll start from the basic and slowly we'll move uh, uh, into details. So feel free to do more hands-on along with us, and also it will cover with the theory and practical. So we'll share all the notebooks with you so that you can practice later on as well, no problem. So yeah, so that's all from my side. And again, I'd like to thank you all for joining the session. So, and if hopefully all have joined who have registered, but if you feel somebody missed, then feel free to message me or in our group so that we can include him or her. So yeah, that's all from my side. Thank you.
Thank you, sir, for letting us know about the schedule. So now we will delve deeper into Odia GenAI's inception and journey. Dr. Kusumlata, an assistant professor at Chadha University, along with Dr. Satya Das, will share their experiences. Dr. Kusumlata's experience in generative AI, machine learning, and LLP, combined with her collaborations with notable figures in the field, brings valuable insights into Odia GenAI's evolution. Dr. Satyaranjan Das, an associate professor at KIT University, is an adept researcher with over 130 research papers and supervision of successful PhD scholars. His area of expertise spans across machine learning, bioinformatics, and natural language processing. So, I request both of them to start with the presentation. Thank you.
Let me start. My screen is visible. Am I audible to all?
Yes,
Yes,
you're
sir.
visible and audible.
So, good morning, one and all present here. Myself, Satyaran Das, as Parul has introduced. Thank you, Parul. So, actually, 4 to 5 years back, we had initiated a project to enrich the Odia language NLP resources, particularly for the machine translation. We had faced a lot of problem at that time to prepare the parallel corpus, but we had succeeded to release 2 corpus named OdiaNCUP 1.0 and OdiaNCUP 2.0, having more than 1 lakh parallel sentences each, which is now available in Lindat LINDAT, Lindat repository for all. So at that time, we had collected Odia English parallel and Odia monolingual sentences from different sources like your Wikipedia website, Odia Wikipedia definitely, books, dictionaries, using different manual and machine learning techniques, including your web scraping and optical character recognition (OCR). So just 1.5 years back, Dr. Shantipriya thought, why not we adopt the Gen AI or generative AI and LLM for the Odia language? As at that time, we had faced a lot of problem so to collect the data. So generative AI, it should be noted, it is not a brand new. Generative AI was introduced in 1960. You can say the Elijah chatbot created by some Joseph Weizenbaum. Fine. But it was not until 2014 with the introduction of this GAN, generative adversarial networks, a type of machine learning algorithm, this which create convincingly authentic image, videos, audio for the real people. So I had also worked in GAN for some biomedical related projects. Then Odia generative AI, in short, we are saying that Odia Gen AI is an initiative to research generative AI and large language models for the low resource Odia languages. Actually, this is the brainchild of Dr. Shantipriya Parida. Definitely, he has started this one. His thought is that we should go for this Odia this generative AI techniques. So the focus research area of Odia Gen AI is to investigate the latest development in generative AI and LLMs, analyze the current method to support the Odia language for different tasks, developing pre-trained and fine-tuned Odia LLMs, which include dataset preparation, model training, evaluation, prompt engineering, and API development, and also deploy in the this Odia LLM models for public access so that more researchers can join and for the commercial purposes, non-commercial purposes, sorry. And prepare the next generation students for this by conducting this type of workshop, conferences, free internship for the students, those who are dedicated and sincere. So many of our this tools and projects what we have released till now that is available in Hugging Face and many other that websites. Now my co-presenter Dr. Kusum ma'am will elaborate in details about our journey of OdiaGenerativeAI, what we have done till now, like details about our data set, tools, project, what we have already done or in pipeline also. So now thanks to all. Now I will ask Dr. Kusum ma'am to take the charge and so thank you.
Okay, hello everyone, and thank you, Rajan sir and Parul. No, the already Satya Rajan sir has told that how they will be uh, motivated to or get into the generative AI. So just I'm going through the what things we have done under this area. So before this, there are some technology which will be used in the whole through the whole workshop, like LLM, which is large language model, and ASR, which is automatic speech recognition, GENAI, which is generative artificial intelligence, and LORA, which is low rank adaptation of a large language model. So before going to this, what is actually generative AI? Itself, the name is indicating that you are generating something by using AI technology. So generative AI means we are describing, we have some algorithms which will be using to create any new content. It can be any audio, any text, any image, just like a chat GPT, as many of us and many are using this chat GPT to generate the text. All of you are using nowadays. So what is actually the motivation behind this? Through Because now there are many large language model which is multilingual, which is supporting itself this Odia language also, but we need to improve the performance for a various tasks like question answering or any content generations, sentiment analysis, which can be improved. So the large language model, which supporting the Odia language, which fails to actually understand the content regarding this, because the Odia is a low resource language. The low resource means we have a less resource, less set of data set to train the models or any other tools which is required for this language. So motivation behind developing this, there is a fees or subscriptions required for using that available LLM models. And there is one more, which is biasness of data and the uses of data which is you are giving to the LLM, also which is in the question, because maybe it happens that the data which is I mean they are giving, which is are not representative of actually the or I can say the representing the whole scenario of your data. So this Odia generative AI is actually the collaborative initiative, which is actually conducting the research based on the generative AI and the large language model for Odia language. Initially, as the Satya sir already told you that initially they have started we have started with the Odia language, but now we also included some language, Bengali and Hindi language also. So initially started with Odia language. So mission is actually to how to utilize the power of AI, artificial intelligence, while developing the generative AI or large language model based technology, or I can say the solution for the development for a Odia languages, development for Odisha or the Odia language through the collaboration among the Odia technology. So the team is here, Dr. Shantipriya sir, Sambit, Swateek, Subhadarshi,
Madam, your
Abhijit.
screen is not shared. Can you share your screen?
I think, sir, I have already shared the screen.
No, ma'am.
It's
No. Oh, I
Yeah, we
don't.
are
I
unable
don't.
to see.
Oh, let me check. But I think I shared that.
Yeah, now it is visible.
Now
Thank
it
you.
is visible. Okay. So
No,
should
no,
I?
now it is visible. Yeah.
Okay. So should I start from the start again? From the starting or?
No, we're good. We can continue from here.
Okay. 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 So these are the team members for this particular generative AI team. And there are some interns for this team, and the researcher, Dr. Guneet Singh, and Dr. Kusumlata, myself, and Dr. Sonal. And there are some data set which are released. Uh, there are more than, I think, 21 data set available, which is in the Hugging Face available. Uh, so these are the some data set we have shown that there are data set for Odia and for Hindi language also. There is for a role play data for English also, and there are some domain specific data also for Hindi also there. And also there is a model available in which is in the Hugging Face, like here for Hindi, which is for Odia, which is based on the LLM MA2. These LLM models, which will be you will be uh, uh, these topics will be discussed in the next session in the deep. I'm not elaborating here what is LLM. The source code available in Odia Generative AI, which is GitHub. And the number of activities we have done here were the research, scientific publication, mentorship, and app development and workshops. The Nipun has recently present the one of the uh, papers, one of the research paper. And this is Odia Genai web app. Actually, this is actually used to extract the data you have to, because you have to extract the data to pretrain the large language model. We have to extract the data from the website. You have to collect the data. For that, you have to just only give the URL here, and then after that you will have that related data, and it will be saved as a text form, or it is JSON line format. So there is one more OLI format which is developed, which is actually developed for a instruction preparation of an instruction set for a Indic language. It can right now it is supporting Hindi language and Odia language. Just you have to give the type of language and the input text you are giving, like which type of the prompt type you need, and the number of question you want to generate, and format of instructions, like questions. And then you have to you can give your URL also. You can also give here PDF document from where you want to be extract the from where it will be generating some instructions. So if you see here that there are generated instruction questions like that. So this is the olive former. And there is a Odia ASR model, which is to means you have to select some audio file, and it will it will be predicting that, it will be recognizing that speech. And here is a demo for Odia GPT model. So I'm running it. So if you see here, we have given that what is the result of dividing the 16 by 4. So it will be generating the result, which is in a Odia language. So it is generating the result. What will be the result if you divide 16 by 4? And then another one question, give an example of palindrome. So again, the answer will be given in the Odia. So whatever the example of palindrome. So if you see, there is a one more question. What is 2 plus 2? So 2 plus 2 is equal to 4, which is given in Odia language also. The text is in the Odia language. So what is generative AI? Question is given. And answer is given in the Odia language. It is explained. It is giving the answer of generative AI, definition of generative AI in the Odia language. Like next, the answer. The question is given in Odia, so answer is also given. Answer is produced in the Odia language. Like the next question, again we are entering the next question, just like as a chat GPT. How to become an AI expert? The answer again given in the Odia language, because it is a Odia GPT model. So this is the demo for Olive chat. So thank you. Thank you so much. This is so can I stop to share? Stop presenting?
Yes, ma'am. Sure.
Yes.
Thank you, ma'am. Thank you, sir, for telling us all about what OdiaGenerativeAI journey has been. Now, moving on, we will learn more about like building upon our understanding. Let's navigate deeper into the realm of generative AI and LLMs. Swateek Jena, a senior engineer at Right Sense Inc., and Dr. Sonal Khosla will revel in the intricacies, drawing from their expertise in product engineering, analytics, and their passion for generative AI, shedding light on Odia Gen AI's endeavors. Swatik Jena works as a senior engineer with Right Sense Inc., and out of their Bangalore office. Swatik has a special interest in analytics, machine learning, generative AI, etc. And he spends his spare time volunteering his knowledge and skills with Odia Gen AI. Dr. Sonal Khosla, an expert in data intensive applications, particularly in NLP, data science, and analytics, brings a wealth of expertise in domains like supply chain management and edtech. Her dedication to mentor individuals in data analytics resonates with Odia Gen AI's ethics. So, now I request them to start with their presentation. Thank you.
Thank you, Parul. Hello, everyone. Greetings for the day. I'm Swateek. along with Dr. Sonal, will take you through this session. Sonal ma'am, could you please share your screen? Well, hey, everyone, if you have any questions, please feel free to drop it in the chat box. We'll pick it up from there during the question answer time. And yeah, great. So we'll go through, in the next slide that we have, we'll go through a list of, we hope the structure is good enough, where we start with understanding what is generative AI, then looking at what language model is, then focusing on the large part of LLM, which is language models. And then we understand what applications impact other terms and terminologies that we might use throughout the presentation. Of course, we'll at the end of it, we'll recap everything. You might things that the next session onwards people will use. So yes, that's the major agenda for this. Again, we wouldn't be able to take questions during the presentation, but yes, we will take your questions from the chat box at the end of this. And also, we hope that any questions that you might have gets answered through the presentation as it progresses. Okay, let's start. Before we get started on LLM, which would be a good segue for the rest of the workshop. Let me take you through first what is generative AI. And generative AI refers to a particular category of artificial intelligence, AI as we call it, which focuses on creating or generating new content, data, or information. What this means is that traditional AI systems are trained on a particular set of data and are programmed to give a particular kind of output. Take, for example, an application that compares two images to tell you how similar they are. Now, you cannot expect that application to write out verses of lyrics for a song, would you? I don't think it would never do it. But that's exactly how traditional AI systems differ from the generative AI applications. Three of the most important characteristics in a generative AI applications are creativity, learning from data, and autonomy. So these are like broader terms. In creativity, we all understand, right? We have seen in news that hey, people are making money by creating stories from using ChatGPT. So creativity is that it creates something new from an input that you provide. They also learn from the data provided. For example, you pass on a CSV file to ChatGPT, and let's say you wanted to summarize it, or you want to ask question and answers on it. That can be done. When we talk about autonomy, it comes from the fact that these systems are independent. Let's say you're not satisfied with an answer that you got as summary. What it would do is it can take your feedback, saying, no, I don't want it, and it will give you a better output or maybe a different output the next time if you want to if you want the answer to be redone. Well, of course, like everything in computer science world, we have different types of generative AI. We could go to the next slide. And as Satya sir mentioned in his presentation, that generative AI is not new. It has been been around since 1968. And why is that important? Because like every generation, there is an iteration of the previous knowledge, and we get something better. So there is no point to understand all the things which are in orange, but it's here so that we have a context of how things were working and what it is now. So one of them is, these are types of generative AI. One is recurrent neural networks. Anyone who has done a bit of deep learning study would know what RNNs are, but still, recurrent neural networks are this particular kind of artificial intelligence neural network that can process sequential data. They're useful for tasks that involve sequential input, such as speech and language, anomaly detection. And the recurrent word in this RNN refers to the fact that the output from the previous step is fed into as an input to the next step. And the reason I've put RNNs and LSTM, long short-term memory, in one place, because they are also a variety of recurrent neural networks. And the problem with RNN is that they don't have a long-term memory. Like if you go back in time, they wouldn't remember what was there before it. So LSTM solves that problem, that it has in memory to give you more accurate prediction from the recent information. That's how like it was a development or an improvement over RNNs. The other part is variational autoencoders, which is we will talk about the word encoders, decoder a bit ahead in the presentations. But yeah, just bear with me for this, that autoencoders are a type of artificial neural network that learns to encode unlabeled data. They are used for unsupervised learning tasks like anomaly detection, image denoising, image compression, or even image data generation. Generative adversarial networks are machine learning models that use two neural networks to generate new data. The goal of GANs is to generate synthetic data that resembles a known data distribution. Things like images, videos, voice outputs. The other part, which is not written here, but it's a part of this image, is flow-based models. These are machine learning models that uses normalizing flow to a model to model a probability distribution. And diffusion models are also a type of generative model that can generate high-resolution images. It's okay if you do not want to remember any of this. These are just how generative AI has evolved from 1968 to we are in 2023 today. So this is it started from somewhere and it's now somewhere. So this is like the in-between of this. So from the next slide, we look at where all generative AI can be applied. This is interesting. The applications of generative AI are plenty. We all know that be it creative or analytical or even health sciences to maybe figure out what molecular combinations for a certain kind of drug would be beneficial. This image is a small piece of where generative AI can make a difference. Like on the left, it's all creative. On the right, it's all analytical. Or in healthcare, when we say it's creating something from scratch about what possible drug combinations can be done. Generative AI typically move away from traditional AI systems in the fact that they possibly can be a one-size-fits-all kind of solution. It sounds if this sounds interesting, it actually gets better from the next slides on. Before we get into the large part of language models, LLM, let's understand what language models are. Now, a language model, by the textbook definition, is a probability distribution over a sequence of words. Assume we have n words in a sentence or a paragraph. A language model, what it does, it can assign probabilities. Let's say from W1 to Wn of the whole sequence. And how exactly do they know how to assign probability? Because language models are trained on large amounts of data of any language. I mean, it depends on what language they're on. And that makes them intelligent enough to do this. So they know how to assign probability to a word in an input. And why do we assign such probability to each word? Because this helps us with the output that would be generated from the model. The probability, which is assigned to each word, tells us what is a good answer to the input what we provided. Imagine a translation model. Okay, if we translate a sentence from Odia, which is my mother tongue, to English, then the model would create a set of outputs, and only the ones with the best probability would be the right answer. Just taking an example from ChatGPT, if you have worked on the APIs of ChatGPT, it always returns back as an array which would have 2-3 answers, but there's a confidence score associated with each answer. So this probability assignment and that is somewhat similar or correlated. We have an example on the next slide, so let's take a closer look at that. So yeah, so for example, if you look at this particular example, only one sentence makes sense, which is in green. And that has the highest probability. And how did the language model know that would be possibly right? Remember that it has been trained on large corpus of data. In that large corpus of data, there is a good chance that two articles like the and the would not be together. That's why it has the least of probability. So the mouse, the cheese ate has 0.01 probability. However, the cheese ate the mouse is a funny statement and would be actually a good one. But it still has a better probability than two articles together. So like, since it has been trained on data set, which we hope that is all absolutely good and correct, it understand what could be more factually, not factually, I'm sorry, what would be more grammatically correct, or what would the output be? So like multiple types of generative AI that we have depending on their qualities, language models are also classified to see them in the next slide. We can do that. Can we move to the next slide, please? Yeah. So the two kinds of language models that we have is statistical and neural. Now, statistical was the first generation of language models, but currently neural is the more popular. Statistical model works on probability. It's like when you are typing a message on WhatsApp, and automatically the next word is suggested based on the context that you are in. In this example, the student opened there can be completed with different words like books, laptops, exams, minds, etc. Neural language models, on the other hand, use continuous representations or word embeddings to make their predictions. Again, word embeddings is something which we will talk about when we dip our toes into the details of language models. So, in short, if I can explain it right now, word embeddings are the input that is fed into the model, because models have no knowledge of text, which is in English or Odia or Tamil. They have no knowledge of it, or images if you input it. They only understand numbers. So any input that needs to be provided to the model has to be in a format that they understand. The conversion of a word to a numeric format is called word embeddings. And when it is fed to the model, that's when the model can start to work on its prediction. Neural language models, of course, since they are a newer generation of models, are used for complex tasks, things like things that classical models would fail to work on, like speech recognition, machine translation, etc. Now let's focus on the large part of language models in the next slide. Great. Now, what's an LLM? A large language model is a language model consisting of a neural network with many parameters, typically billions of weights or more, trained on large quantities of unlabeled text using self-supervised or semi-supervised learning. Textbook definition, but let's break it down to understand what it is. We spoke about unlabeled text. Unlabeled texts are those which don't have any tags associated to them, just simple raw text. So given an input, I wouldn't say, hey, this is a pronoun, this is a noun, this is an adverb. No, it's just unlabeled text that is fed into it. For example, GPT-3 of OpenAI has 175 billion parameters. GPT-4 has surpassed it by a lot, and has been trained on 45 terabytes of data from various data sources. That's why it's a large language model. As for any computer systems, there is always an architecture behind models of how they're developed and everything. So the basic unit of all LLMs are transformers. Because if I can tell you the full form of GPT itself, as everyone would know, it's generative pre-trained transformers. If we try to understand LLM first, it's better to understand transformer a bit from the next slide onwards, which are the fundamental building blocks. So transformer architecture that you see on the right, do not pay attention to the image. I have a simpler image ahead. So they are was introduced in a paper called Attention is All You Need, published in 2017. And there are 7 important components. The reason I've highlighted only 2 of them is because we'll focus on those 2. The others are really good to know. Of course, I'll skim through all of them. But I'm sorry. But yes, we'll just focus on these 2. Since we also saw variational autoencoders, generational autoencoders before. All right, if we move to the next slide, again, I'm saying it's absolutely understand if you do not, it's okay if you do not understand everything in detail, but just focus on 2 words, encoders and decoders, which are in teal color. So now the first thing, we'll start from the left, which would be inputs. If you see on the left bottom, we have inputs and input embeddings. Now, when I said before that generational AI models, why generational AI? All models, they do not understand words or text as is. Neither do they understand images if you send them. So, sorry, one second. Yep. So whenever you want to feed something to a model, a model would only take in numbers. So these inputs have to be converted into a numeric format, and that is called input embeddings. The moment you input something, let's say a sentence in English, it gets converted into its corresponding encodings. So that's called input embeddings. Now there is something called as positional encoding. If you see there is a plus, what is positional encoding? The way large language models differ from other generative AI models is that they understand the position of words. Again, we go back to the mouse ate the cheese. Makes perfect sense because large language model understand that the article should come before the subject, and the action should, even the article should also come before the action, after the action. So positional encoding is important because it's crucial in determining the meaning of the sentence. So by incorporating positional encoding into the transformer architecture, GPT can more effectively understand the order of words in a sentence and generate grammatically correct and semantically meaningful output. After your encodings are done, we are done with input embeddings, we are done with positional encoding, right? So first your inputs is converted into a set of numbers. Then they are also encoded positionally, that hey, this comes here, this comes after x plus 1, that way. We pass it through an encoder. Now, encoders is a part of neural network that processes the input text and generates a series of hidden states that carry meaning and context. A transformer can have multiple encoders. Like it's just one in the picture for representation. That's why it's n of x. There could be multiple encoders, one after the other. After this, we do have the decoder. Now, if you look at it, the encoder just transfers the representation of what was there before, but from the right bottom, you see the outputs that is being shifted. So the outputs during the decoder gets this output from the model, where it looks. So the decoder gets the output from the model, where it learns to guess the next word by looking at the words before it. That's what that's what the decoder would do. That the positionally encoded input that it has received and the positionally encoded output that it has received from the model generates the output sentence based on the encoded input sentence. So the input comes in handy. Input says, hey, these were my encodings. The output from the model comes in saying, this is my encoding. And the decoder decodes the fact that how do you convert an embedding into semantically meaningful and grammatically correct output. After that, we have two more layers. These are like functions that generate a probability distribution for each output that the decoder generates. And when you assign a probability, we saw in that example, the cheese did not eat the mouse, but it's the mouse which ate the cheese. So that is where the probabilities get assigned. And the final output comes from here. So the part of encoder decoder is simple, that encoder encodes input, encodes positions, and decoder decodes the output with the help of input encodings. This is all we have to take away from the slide. And this perhaps was the most complicated part of trying to explain what an LLM internally contains. Now, the LLM timeline that we have. Currently, every now and then, if you look up the news, there are multiple LLMs which are introduced into the market. This image has been picked up from a survey paper called a Survey of Large Language Models. And it's an interesting read. It talks about most available LLMs in the market today. Starting from the left top is the starting, 2019, when Google T5 came in, to OpenAI's and GPT-4 Llama from Meta. And also, this particular LLMs are only those whose parameter size is greater than 10 billion. That's why the list is smaller. There are many LLMs here, some of which are open source, others are commercial, and all of their capability are getting advanced every day. After GPT-4 was introduced, they also introduced GPT-4 Turbo 14 days back. And yeah, please go through the paper if you want to understand the details of how LLMs have evolved since the time of Google T5. We're not going into the detail of everything, but it's good to know that Google has BARD, Google has had T5, Meta had Llama, and of course, ChatGPT uses GPT 3.5 and also GPT 4. Yep. If we go to the next slide, there's an interesting concept, which is Moore's law. All of us are familiar with the transistor part of Moore's law, the processor part of Moore's law. But the NLP's Moore's law says that the performance of natural language processing models will continue to improve exponentially, following a similar trend for Moore's law for the number of transistors on a chip. So we can see the exponential increase in model size from the graph here, starting from mid of this is 2018 or 2017 mid to 2021, the exponential rise. This is just here to lighten the mood. We are not going into details of the hypothesis. We'll jump into something more, which is around the types of LLMs. So we just spoke about encoders and decoders. That will come in handy right now, because LLMs are classified on the out of 3 types based on what they use.
Pardon, Swateek, but you are not audible.
Hey, I'm sorry. Where
Yes,
did
now you.
sorry?
After types of LLM.
Perfect. I'm so sorry. I think I muted myself. Okay. So we just spoke about encoders and decoders in LLMs, and that will come in handy right now. So broadly, LLMs are classified based on that, which is autoregressive, encoder, decoder, and masked LLMs. Autoregressive models use decoders only. Encoder, decoder, obviously from the name, they use both. Google's T5 and masked LLM models use encoders only, and BERT is an example of this. Let's dig into a bit of the detail from the next slide onwards. Autoregressive LLMs, they're also called as feed-forward model, are models which predict the future word from a set of words in a given context. So these models are useful in generating texts, exactly how ChatGPT works. You put in a query and it generates a set of text as a response to your query. I'm talking about a very specific model of ChatGPT. I'm not saying DALL-E or anything. So is Bloom. So it's quite helpful or useful in text generation. Next slide, we have masked LLMs. So masked language model is where a model uses the context words surrounding a masked token to try and predict what the masked word should be. So this is like, fill in the blanks kind of task that we used to do in schools. These models, they work great in sentiment analysis, word classification, etc. BERT, which was introduced as a pre-trained NLP model by Google researchers in 2018, is a masked LLM. So now that we have covered the types of LLMs, we can jump into where all applications that we can have. So LLMs of late have found a variety of applications and also in a vast number of fields. So we have been able to generate content, for example, a cover image for a musician's album based on the song's lyrics, or a travel itinerary to your planned destination. Another is part of speech tagging, used quite a lot in NLP. Part of speech means the tagging the words in a sentence to be nouns, pronouns, verbs, adjectives, etc. Question answering are mostly implemented in chatbots that might solve a single or multiple purpose, like ChatGPT or any application on top of GPT. For text summarization, it could be rewriting the first draft of an article. So you might have a 240-word length essay, but the model can summarize for it to you in 60 words. With conversational AI, which is using speech to text or text to speech, the language models are quite helpful with their capabilities because we talked about how they maintain memory, the type of encodings that they can contain, the type of memory that they can hold. So they can also be used for machine translation, like from one language to another. This is exactly and heavily used in the work that OdiaGenerativeAI does behind the scenes. And if you've heard of GitHub's Copilot, that's code completion, something that works great when powered by LLMs. So this was my bit of introduction to generative AI. and a small dip into LLMs. Now over to Dr. Sonal to take you folks into deeper waters. Thank you so much.
Thank you, Swateek. I hope I'm audible.
Yes, ma'am.
Okay, thank you. Thank you, Swateek, and good morning, everyone. So I will take you more towards into the details of the LLM and how a complete LLM life cycle and how a complete application can be developed upon it. Before moving further, we'll just iterate over this the diagram, which actually shows you, how you can build an LLM application. So the first of all, because as we saw, Swatik mentioned that LLM has different applications and it can be used with a variety of problem statements and tasks. So the first, when you start with building an LLM application is to, scope down what is your requirement, what kind of problem you want to solve. And so you define your own use case. Then the next is to either you choose an existing model or you try to pre-train your model from train your model from scratch. Because we already have a lot of LLM models available. The most of common approach is to actually use the pre-trained models and apply it or adapt it for your own particular use case. But again, training a model from scratch is also possible, which has certain limitations, which we are going to, we'll talk about it later. Then you can actually, once you have decided, what kind of approach you want to use, there are, how you can make your model adapt and align to your particular use case. So there are different approaches to it. One is, prompt engineering, or the second one is fine tuning. Or, if the, model does not respond in the way you expect, you can actually, iterate on different strategies and evaluate it. And then, some sort of human intervention is always beneficial, because again, it's a machine and, it is not going to respond in generating language text the way the humans are going to, build. But so this is, you can adapt and align a model as per your specifications. And once you have, you're satisfied that you have a good model in place, which is, providing you results which as expected, and, it's responding in the way you expect, then, you would optimize and deploy the model for inference. We are going to talk about, what does fine tuning mean, what is prompt engineering over a period of time. But we, just going through, take you through an overview of the entire life cycle. So once we have the model in place, we are going to optimize and deploy for inference. And then you can actually build, an application layer on top of it to actually interact with the user or the customer for a seamless integration. I'll talk about each of these terms that we have, discussed in the life cycle, but just taking you again through the LLM application. So basically, what kind of use cases the LLM is able to solve. So these are some of the, possibilities which you would try to use the model for your own purpose, like, summarization, where say suppose you have a history of, say, suppose, a conversation between a customer and a vendor, and you would like to summarize, what is the outcome of that conversation. So summarize it, you can define, model to summarize the conversation and, get some insights from it. You might also ask the model to actually rewrite a particular piece of text in a different language format, and so on. So, there are different use cases the model is able to work upon. We'll start with some, basic terminologies and then see, what does it mean. So say, suppose we are using an already built in LLM model, and we have a model and we want to, make the model respond or communicate with us in a certain manner. So say suppose, a simple task that we want the model to perform is to, provide, we provide a question to it and it responds with an answer. So in LLM terminologies, there are certain, words that are assigned for what each kind of task. So when you provide an input to a model, it is generally called as an prompt. When the model provides you an output back, it is called as completion. So as we see in this diagram, we provided a question to the model. The model responded with an answer. So the answer over here is the completion. And the entire process of, providing an input and getting an answer from the model is actually known as inference. Now, it's not always that, the model is going to behave in a way as expected. They might, deviate from the output and may not respond or may not provide you the correct answer. So the art of actually modifying your prompts or modifying your inputs in such a way that you get a better output from the model, that is actually termed as prompt engineering. So now how the prompt engineering can be done over here. You if you give some certain extra information to the model to that, okay, suppose for example, I have this example over here, 2 examples. So in the second diagram, what we see over here is that we want that there is a certain review, and I want the model to actually classify the review whether it is a positive review or a negative review. Now, in the first diagram, we see that, we provided an input to the model. It said that, I loved this movie, and we want the model to actually classify it as positive and negative. So, we see that the model performed well. It classified it as positive, which is good. But in some cases may not give you the desired output. So we provide certain extra information over here. And what extra information? Like suppose in the second diagram, we see that we want the model to actually classify the second review. I don't like this chair, and it should ideally respond as negative, which is the case in this example. But to make the model perform better or to make the model to understand better, we provide certain context to it, certain more information to it in the form of examples. And we gave an example over here. Okay, classify this review. I love this movie, and the sentiment already is given. So you're actually providing some sort of labeled information to the model, which says that the sentiment is already positive. The model takes this as an example and then classifies the second review as negative. So we are giving certain extra information over here to the model, and this information is certain examples. With on the basis of this context information, they actually behave. Now, the idea of providing these examples is to make the model learn better, make the model understand better, and in situations where it is not providing us as the expected outcome, you can actually make the model perform better. So we have a certain context window or a certain size limit on which how many examples you can provide to the model, which is actually called as the context window. And it is some few thousand words, and this actually helps the model to perform better. But if suppose the model is already behaving well, then in that case no examples might be needed. So when you are doing prompt engineering over here, there are different ways this prompt engineering can be done to make the model perform better. It could be zero shot inference. That is, you only provide the input and expect the output from the model. But if you're providing one example to the model, and then in that case, it is known as one-shot inference. But if in case, in situations where the model is not able to understand, you might also provide some multiple examples, which is also called as in-context learning or few shots inference. So this entire process of, making the model respond in a way that is expected by the user, this is called as prompt engineering. Now, this is the simplest method by which you can interact with the model, and you're assuming that you already have an LLM model which is behaving well and is responding to your output as expected. But there are certain limitations to this approach as well. Now, there is a limit on the size of the context window. And, as you can see over here, there is a limit. It occupies, when you provide certain examples to it, it occupies space, and this space is limited. It is generally a few thousand words. So it occupies space, and there is a limitation of how many examples you can actually provide to it. And it is good to work on small models. So this approach is good, but it works on small models. But as the size of the models become larger, this is may not be an ideal approach. And in situations where the model is not trained on certain specific data set, or in specialized domains, it is not a very good way, because the model may not have a background understanding, may not have a background information, context, and then it may not respond as expected. So we actually then talk about different ways how we can improve the model, or how you can make the model to perform better. One way of doing it is that you can train your model from scratch, but there are certain again limitations attached to it. When you are training a model from scratch, you require a huge amount of data set to make the model learn, to train the model. Then you require a good amount of computing capacity. It also requires time. This is going to take a lot of time, because you're collecting, you need to have a good size of a data set. The data set needs to be of good quality. And then, training the model is going to take time. So the other approach that is used is generally in LLM terminology, it is called fine tuning. So you already have a LLM model. As we saw, there are so many models available in the market. Most of them are also open source models. So you already have the model with you, but you retrain the model in such a manner that they actually perform for your application or for your use case. So in that case, this is called as fine tuning the base models. And it's the advantages of fine tuning these base models is that they sometimes, in situations like in certain domains like medicine or finance or science, there are certain vocabulary which is very specific to that particular domain. Okay, so in that case, the model has not learned that terminology. Even when, doctors, when they write a certain prescription, they have a certain way of writing, the prescription, and they have certain words, abbreviations that they use for different purposes, which the model has not, a general purpose model has not been trained upon. So it's a good idea to, actually retrain the model on that specialized data set, or on that specialized domain, and then reuse it for your own use case. So this is called as fine tuning. And so what is the advantages of doing fine tuning is that they have a better understanding of the domain specific vocabulary. Finance has, a set of vocabulary which is very specific to their domain. They understand the context better. And then in that case, it results in models that works for, highly specialized domains. Now, when we are building models, specialized domain models for our purpose, then in that case, we have a good example of OdiaGenerativeAI again. We are retraining the model to work on Odia language. So it understands, every language has a different kind of grammar. They have a different kind of, how the language behaves. So when we retrain the model for our language, then it understands the domain, the language specifications, and then it performs better. So this terminology is called as instruction fine tuning. So in instruction fine tuning, we already have a base model over here. And this model has been, trained on a huge data set. The data is generally taken from web, from the internet, books, and then it is, passed through different data quality checks and so on. And then, we already have a base model. Now what we want to do is we want to make the model work upon our own domain or our own application, and which is called as fine tuning. So when we want to do this fine tuning, we provide them domain specific data set. And then we have a fine-tuned LLM model, which is going to, again, we can use it in a similar manner. We provide a prompt and then it provides a completion. So then it interacts with the user and, it behaves as expected. So the idea of fine-tuning is that it improves the performance and the adaptability of, how the language models have been trained earlier. We provide them some domain-specific data, which is called as instruction prompt. And this instruction prompt is most often it is the supervised data set. So it's kind of a supervised learning where you provide labeled data set to the base LLM, and it learns from the domain-specific data sets, and it understands the domain-specific complexities. I will again take you through the application life cycle over here, the LLM application life cycle, that we have defined the scope. We have chosen a model. Now, what kind of model we want to choose depends upon what kind of use case we have. As discussed by Swateek, there are different types of models like encoder only, decoder only, encoder, decoder. So they have been trained differently. The architecture followed is different, and then in that case, they behave differently to different use cases. So based on what is your use case, you're going to choose the model. Try to prompt engineer onto it to see how the model is behaving. Now this also involves evaluation. You would see the output, what kind of output you're getting. If the model is performing well, then maybe it's not needed that you actually do fine tuning. But if required, you would actually retrain the model or fine tune the model to perform on your kind of use case. Evaluate again, and then this is kind of an iterative process. Now, evaluation most often is accurate when you align it with human feedback, which we are going to talk about later. And then we are going to move further into, integrating the model into the application. This is an example of, how the model is provided input. So as I spoke upon that, you provides a supervised data set over here. Supervised in the sense you have an instruction data set, which is actually a data set of prompts and the completion. And then, you create a model based upon that. Now, over here as well, then, there are certain complexities when you're actually fine tuning over here. That, when you have a pre-trained model and you fine tune onto it, most often, this fine tuning can be done to update all the parameters, or this fine tuning can be done to update only specific parameters. Now, both have, advantages and disadvantages. So we'll just talk about it. So, if you are fine tuning on all the parameters, which is called as full fine tuning, it requires more computation power and memory is needed. But in that case, when you're doing this, it is actually performs very well on a certain task for a certain application or for a certain use case, but it may not perform well on different other tasks. So which is actually called as, for the term, it's called as catastrophic forgetting, which actually means that, you have fine-tuned the model, all the parameters of the model have been updated, and it performs very good on a particular task, but it may not perform for the other tasks. But on the other hand, because it requires a lot of computation power and memory, it is better to actually only update specific parameters, and which is called as parameter efficient fine tuning. That is, you're not updating all the parameters, but you are only updating certain parameters, which is more faster and may perform well, may or may not perform well for your particular task. So as discussed that you can do fine tuning, but even when fine tuning is done, we need to evaluate the model. There are certain metrics that can be used to evaluate the model, but it is always better to evaluate with human intervention, because the metrics may evaluate because it's all it's statistics behind it. So the metrics evaluates on the basis of the how the encoding has been done, and how the input was fed and so on. But we need to check the language specific complexities, how was the grammar, and most often LLM models is likely to generate harmful content, or if you're generating speech, then in that case it could be a toxic tone or a voice. And sometimes the LLM models also provide detailed information about the certain dangerous topics. So it is always better to actually align it with human feedback, which is called as reinforcement learning, human feedback. And the objective is to align it with human preferences, to see whether it leads to answers which aligns to the human understanding. The human can understand the context, they can understand the fluency of the language generated, and so on. But most often, three terms that are very important over here is the helpfulness, honesty, and harmlessness. So the objective is that it should be more helpful, it should be honest, the output generated is good enough, it's not biased, and it's not harmless to the it's actually harmless and does not generate harmful content.
Dr. Sonal, a time check. We have 7 more minutes.
Yeah, sure. Thank you. So there are certain common evaluation metrics in addition to human intervention. One is perplexity, which actually measures how well a model predicts the text, and what is expected, and it's predicting what is expected. So lower values indicate a better performance. In cases of machine translation, blue is the score, which stands for bilingual evaluation study. It measures the overlap between the generated text translation and the reference translation. So it is more often used when you're doing machine translation. Then another metric that we have is Rouch, which is used to evaluate text summarization. And again, human evaluation is the gold standard, because they can assess the fluency, they can assess the quality and the relevance of the generated text. There are certain limitations of language models. One is knowledge cutoffs. So for example, if the model has been trained in 2020, it will say, suppose a model has been trained on certain historical data, and so it is only going to understand the events that had happened until 2020, and it does not have additional information about the events that happened after 2020. So it has a knowledge cutoff in terms of when the content was fetched from the internet, from different sources, and when it was trained. The other limitation is that it cannot still handle complex mathematical calculations and tasks, and it's also makes inferences on incomplete information. So a model is always going to give you an answer, even if it is not relevant, it does make sense or not. So they have a tendency to generate information even if they don't know the answer. So it might lead to some sort of incomplete information, it might lead to irrelevant information, and so on. Then the other challenge is that languages are dynamic and they evolve over time. So some LLMs may struggle to keep up with the linguistic changes. In such a situation that there is a knowledge cutoff, or it's not able to provide information, we have another methodology that is try to overcome the issues. and which is called as retrieval augmented generation, which is actually a, you say, suppose you provide a question to an LLM and they are not efficient enough, or they have a knowledge cutoff, they are not able to retrieve information beyond a certain date time, then in that case, through retrieval augmented generation, they can actually, look for different sources, external data sources, fetch the data, and then provide an answer response to the user. So this is a framework for building LLM powered applications that can retrieve information from external data sources. So it actually kind of handles some of the limitations of LLM models, and it improves the relevance and accuracy of the completion. Now, because the LLM always responds to your questions, it provides you an answer, but it may or may not be relevant. So in that case, it fetches data from external data sources to make it more relevant and accurate. We now this is how an application architecture would look like. We already saw that we need a if you are building an LLM application, these are the different layers that it would have. One is the infrastructure. You would require some data storage capacity. You're going to do computing capacity. So you all require, at the bottom layer, you would require certain infrastructure. Then you might have different information sources. If you're building a RAG model, then you might have some external data sources. You have an optimized LLM model. You have generated some outputs, and you know how the model is behaving. You have evaluated it. And on top of that, you can actually go ahead and build certain application interfaces. Just a last, there are certain, ethical issues in AI. I have not taken all of them, but these are some of the common ones that, because the LLMs are trained on large data sets, if the data set is already containing some biased information, say suppose in the case of political biased information, then the LLM is also, expected to respond in certain biased manner. So there is some sort of a bias associated over here. Then explainability, we do not know.
We have two more minutes. Oh,
Yeah,
sorry,
sure.
1 more minute.
Yes, I'm done. Yeah. So then the other is explainability, where you consider that, they are black boxes and we do not know how they come to the conclusion. And the other, if external data sources have been taken, then we have privacy issues as well, that, from where the data has been picked up. I think I'll leave some time for question and answers. So if you have any questions, yeah.
We have a raised hand from Kanu. So do you have any question? You could unmute yourself and ask.
Yes.
Kanu Charan, can you hear us? We do not have any questions on the chat box as well. So, yep, thank you so much. We have a question from Rakesh Kumar Raut, which is, what is multi-agent and single-agent framework?
So we will go through these topics later in detail, and we can talk about it then.
All right. Well, thank you. We'll wrap up our time and up for the next session. Parul, over to you. Thank you so much for the comprehensive answer.
Thank you.
Thank you, Swateek and Dr. Sonal, for such a wonderful presentation. Moving on, to cap our workshop, we are honored to host Dr. Raj Dabre, a distinguished researcher at NICT Japan. His rich background in neural machine learning translation and natural language processing, showcased through notable publications and committee roles in esteemed conferences, promises on enlightening discourse on Indic natural language generation. Raj Dabre received his MTech from IIT Bombay, India, and his PhD from Kyoto University, Japan. His research interest centers on natural language processing, particularly neural machine translation for low resource languages, and on model compression and computing efficiency. I request Dr. Raj Dabre to start with his presentation. Thank you.
Hi, am I audible?
Yes,
Well,
sir, you are
Yes.
audible.
Are my slides visible as well?
Yes.
Okay. Thank you so much for the kind introduction. Yes, my name is Raj. I am from NICT Japan. And the title of my talk is Advances in Indic Natural Language Generation. And this talk is the culmination of a lot of works resulting from the collaborations between AI for Bharat, Microsoft, NICT, A-Star, University of Edinburgh, and IIT Madras, of course. So already you have introduced me, but I'll just give you a quick background. I did my master's in IIT Bombay, and then I did my PhD in Kyoto University, both in computer science and AI research. And then I started work at NICT from 2018, and my initial focus was a continuation of my PhD on multilingual machine translation. And then I expanded to natural language generation with a specialization on Indic languages and Creoles. I have interest in neural efficiency, where I like to compress models and see if I can train models more efficiently. And as for my collaborations, I organize the workshop on Asian translation, mainly adding support for Indic language machine translation. And I also collaborate with a bunch of universities, mainly via interns and students who come to visit NICT. So let's get right into it. What is natural language generation? The best way to understand it is via certain tasks. So we all know translation, where you have an input sentence and we would like its translation in another language. We have the case of paraphrasing, where you have a sentence like, I love to eat fruits, and then the paraphrase would be, I love consuming fruits. We have summarization, where we have a document and we'd like a brief sentence summarizing the entire document or paragraph. And then we have question generation, where we have something like a name and then the question that describes that name. It could be name, place, it could essentially be anything. But right now, it's a very simple case of name and then the question that answers that name. So the main challenge behind getting natural language generation to work is data. We don't have much, unfortunately, especially for Indic languages. Modeling, what kind of model is very good for solving these tasks? And the key solutions that come across most of the works as very successful is data mining. Obviously, we have to get more data. And then there is pre-training, where we leverage an abundant amount of monolingual data to compensate for the shortage of supervised training data. So why is Indian languages important? We are all Indians, we know this, but I'll just cover it for completeness. We have 4 major language families. We have 22 scheduled languages. Only 10% of our population, or even less, consists of English speakers. And 8 languages are in the world's top 20 languages, and 30 languages have more than 1 million speakers. If you look at the right side, you can look at India's user base, internet user base in millions. And from 2011 to 2021, in a decade, we have gone by 7 times in terms of number of users. The number of English users is increasing, of course, but the number of Indic language users are exploding. So it means there is a huge demand for natural language generation for Indian languages. But what is missing, as I said, there is a dearth of pre-training data and models. There is also the training supervised data, training data for natural language generation problems, and then the models and evaluation for these problems. Models to solve the task, and then evaluation to tell us whether we are doing very well on these tasks or not. So in this talk, I'll be covering mainly 4 things. One is the Indic BART and the Indic NLG benchmark, which were 2 of the foundational works for generative models, specifically focusing on Indian languages. Then the Indic Trans2 model, which is our current state-of-the-art machine translation model for 22 Indic languages. I'll be talking about machine translation using LLMs and prompting. This is some work which was recently accepted to EMNLP. And then finally, Indic MT evaluation, where we try to do reliable evaluation of Indic machine translation. And hopefully, seed some ideas for general purpose NLG evaluation. So starting out with Indic BART, as I've mentioned before, our main problem is we have very little or almost no supervised data. If you talk about languages like, let's say, Odia is still considered as a low resource language. But then if you go to languages like Kashmiri, there is almost no parallel data or training data. So what is the solution? Monolingual data is typically more abundantly available compared to parallel data or supervised data. So we want to pre-train our models on monolingual data. So how did we do this? We have a huge amount of monolingual corpus. So when IndicBART was done, we had the IndicCorp V1 model, but now there is a V2 model, which is a lot bigger than IndicCorp V1. And another larger, let's say, data set called IndicCorp V3 is also in the works. So this IndicCorp V1 consisted of about 458 million sentences. So that was roughly around 4.5 billion tokens at least. So the way we did is we worked with the text infilling training approach, where you take an input sentence, you add some noise to it, and you ask the encoder to encode this noisy sentence and the decoder to generate the denoise sentence or the correct missing words from that sentence. So there is one option we have where we can convert all the Indic language script into the same script, which is Devanagari typically. And then we have a variety of models. One is a separate script IndicBART model where all the languages are represented in their original scripts. There is a unified script IndicBART model where everything is mapped to Devanagari, with the exception of English, of course. And then there is a Indic-ALBART model where instead of having separate parameters for every layer in the encoder and decoder, we share the parameters across the layers. So this leads to a very compact models. And these are some training details, but just to simplify it, we used a fair bit of compute, but it only took 5 days to train our models. And we have pre-trained models ranging from 97 million parameters to 244 million parameters. And just to compare, there is an MBART model, which was already trained, which is not specific to Indic languages, and that has 611 million parameters. So our models are more compressed. So what is script unification? Just to give you an idea, these are two South Indian language scripts, and we just map them into Devanagari. Since all of these scripts are phonetic, it's very straightforward. We have the Indic NLP library or any transliteration library that you can look at. And what is infilling? As I mentioned, you take a sentence, something like "Mujhe bhashantar pasand hai," and then you take a word or a phrase and you mask it out. In this case, I've only masked out a particular word, but you can mask out an entire phrase. Like, for example, "I love translation" could be one sentence, and you mask out "love translation," and that would be the input to the encoder, and the decoder would have to predict "I love translation." So what this does is it allows the model to learn some language modeling priors or probabilities. And therefore, we don't need that much of background knowledge when doing machine translation. Most of this knowledge is somehow incorporated during this monolingual denoising pre-training stage. So we did evaluations on machine translation, where we took some small amount of Indic English and English Indic parallel data, and we fine-tuned or trained models from scratch. So if you look at these results on the right-hand side, the blue bar shows what happens when you have a model trained from scratch for Indic EN and EN Indic directions. The red bar shows what happens when you use the MBART model, which consists of 600 million parameters. And then our IndicBART model, which consists of only 244 million parameters. And we can see that despite IndicBART containing fewer parameters and potentially lesser data than what MBART 50 has seen, we are still able to outperform it, if not are competitive with the larger models. So this means that it is very important for us to consider language family specific models and maybe not have that much parameters. When you don't have those many parameters, you have the opportunity to have compact models, which are more easier to deploy on limited resource infrastructure. Just to compare, there is the Indic-ALBART model, and as I mentioned, it is 97 million parameters. And of course, compared to the full-fledged Indic-BART model, it's going to be weaker because the parameters are lesser, about 2 times. But we found out that it is possible to improve the quality of this small model via knowledge distillation. I recommend looking up on sequence-level knowledge distillation if you haven't. But it is essentially a way for us to distill the capacity of a larger model into a smaller model. And so we are able to raise the performance of the Indic-ALBART model from 28.83 to 30.32 for Indic to EN translation. And the same is the case for EN to Indic direction. So it means that even if you have compact models, you can always leverage knowledge distillation to get an improvement in performance. We also saw some very nice zero-shot performance, where what we did was we had unseen languages during pre-training, such as Nepalese and Sinhala. We didn't include the monolingual data for them. And then when we fine-tuned our Indic BART models on supervised data for Nepalese and Sinhala, we found out that compared to a scratch model, which is over here, the Indic BART fine-tuned models gave significant improvement. Note that we had to convert all these scripts to Devanagari to make it work. But long story short, Nepalese does share a script with Hindi because Nepalese is always written in Devanagari. So pre-training helps even if the languages are not present during pre-training. So it is a very nice observation. And what happens when you don't have the data during fine-tuning? So what we did was we fine-tuned our Indic BART models on all languages except for Kannada English and Punjabi English. And what happened is, when we compare against a model where all the data was seen for all language pairs, and then a model where a few language pairs were missing, then actually those unseen language pairs also have some performance, which is zero-shot performance essentially. So what it shows is that these models, pre-trained models, also enable zero-shot transfer between language pairs during generation. We know that it works well during the natural language understanding, such as classification tasks, but we also showed that for generation tasks, it works well. So a blue score for Kannada English of 27.5 without any parallel data at all shows that we have a huge potential for zero-shot translation. We also did some work on summarization, but in the interest of time, I'll skip it. You can take a look at the slides later. So we got motivated by our work on Indic, machine translation and Indic BART, and we realized that, okay, now that we have the pre-trained models, we can actually start tackling some natural language generation problems. And to that end, we created the Indic Energy Benchmark, which consists of natural language generation data sets for 11 languages and 5 tasks. We contribute the first large-scale data sets, benchmarks, and models for Indic natural language generation, where we collect a total of 8.5 million examples overall. By the way, this does not include machine translation. It is only for these 5 new tasks, except machine translation. And we show that language family-specific pre-trained models are once again better than generic ones. I'll show you the results soon. And we show that although our models are 2 to 3 times smaller than larger models, we are competitive, if not better. So what are the tasks? One is biography generation. So if you look at the Wikipedia page, you'll have this info box for a specific person. And then what we want to do is we want to convert this info box into a sentence that summarizes this info box. Typically in Wikipedia, there is this introduction sentence or the first sentence which kind of summarizes this overall. So we extracted this information from Wikipedia. We have headline generation. Now you know that there are many news websites, right? Every news article has, let's say, a body or a document, and then there is a headline. So we essentially just extracted this information, and then we had a pair of document and the headline. This is very straightforward to create, but we had to crawl a lot of data. Then we have sentence summarization, where we want to have a sentence and then compress it into a smaller sentence. So if you think about it, if you have a news document and you have its summary, and then you try to summarize that summary, that looks like the headline. So our sentence summarization task was, given a document summary, convert it into its headline. So we essentially compress the summary into a single short sentence, which can be used as a headline. So this is the task of sentence summarization. We have 2 more tasks. One is paraphrase generation. You all know what this is, so I'm not going to explain too much. But the way we did it was we took the parallel data from Indic Trans V1 from the Samanantar data set, and we used English as the pivot language. So what happens when multiple sentences have the same English sentence as the pivot, those sentences are paraphrases of each other. We had to do some cleaning, but essentially we managed to get a huge amount of paraphrases. Finally, we have question generation data set, where we have the squad data set, which was originally in English. We got it translated into multiple Indic languages, and we did some manual evaluation of the dev and test set splits to make sure that they are not containing bad translations or bad quality question generation pairs. So with this, we got a 8.4 to 8.5 million entries or training data points. And then we used them to train multilingual generation models. And this is the result. The y-axis shows the accuracy or the performance on the Indic NLG benchmark. We evaluated this using Rouge and iBlue as 2 metrics. And then on the x-axis, we have the model size. So the Indic BART models contains 244 million parameters, and the MT5 model consists of about 300 million parameters. So it's large. And what happens is we see that although MT5 has focused on way more languages and seen a lot more data, our model tends to perform better. By the way, this small point, Indic BART no Indic cop, is essentially a model trained from scratch without any pre-training. But yes, pre-training improves performance over a model trained from scratch. And then it is definitely better compared to another pre-trained model which doesn't focus solely on Indic languages. So this is a very nice outcome that we've observed as a result of pre-training. Some results specific to, let's say, all the individual tasks. You can see again that our Indic BART model in the last column gives the best possible performance. You have SSIB, which is Indic BART model without any script mapping to Devanagari. It performs almost as well as the one with script mapping, but it is definitely better than anything that uses no pre-training or using MT5. So it means that there is definite value, once again, in focusing on language group-specific models. So now that we have successfully managed to get a pre-trained model, we managed to get some generation tasks, we decided to revisit machine translation because data was becoming more and more abundant. And we ended up with what we call as Indic Trans 2. It's the success of Indic Trans 1. So our contributions for Indic Trans 2 were a huge number of mined sentences. In Indic Trans 1, we only had around 100 million sentences, or a lot less. But for Indic Trans 2, we had 232 million mined sentences. And the other major contribution was seed sentences or human translated sentences. So this covers 800,000 seed sentences across 22 languages. We created robust manually checked benchmarks in form of Indic 22 Gen and Indic 22 Conv for multi-domain and conversation translation benchmarks. And then, of course, we came up with these models, which are state-of-the-art. We compared against existing models, and we found that we are better than all of them. And specifically, this is the first model that supports all 22 scheduled Indian languages. It is also available with the MIT license, so you can use them for commercial purposes, whatever you want. Indic Trans 2 is also being deployed in Wikipedia and Wikimedia, and it is also being used in some publicly available machine translation services, also the services provided by my company, NICT. So how did we solve the data problem? Well, what we did is we took a lot of monolingual data, and we split that monolingual data into comparable documents, monolingual non-comparable documents, and we did a fair bit of cleaning. And eventually what we did is we used the comparable and monolingual data and some multilingual representation models to mine a huge amount of parallel data. As far this is the mined part of the data. We also have this human data, which we call as BPCC human. By the way, BPCC stands for Bharat Parallel Corpus Collection. And BPCC human is essentially we take some data from Wikipedia, daily conversational content for low and high resource languages, and we have language experts check and translate these documents. We have multiple levels of checks to make sure that people didn't just use Google Translate to translate sentences. We made sure to compare with Google Translate outputs, and if we saw any outputs which are too similar to Google Translate, we rejected them and asked for a retranslation. This involves a lot of money and time, so yes, it was thanks to the effort of a lot of translators. So our contributions, once again, in terms of mine data for every language, we had a lot of mine data for most of the high resource languages, but for the low resource languages, we were only able to add a small amount of mine data for languages like Bodo, Konkani, and so on. But that being said, we have a lot of data, and 126 million is a representation of a very highly cleaned amount of data from the 232 million pairs that we mined. We also have seed data, and seed data here, you can see the numbers look very nice. As over the existing data in red, we have also added a huge amount of newly added data. And this results in 800,000 pairs spanning 22 languages. Once again, you might ask the question, why do we need another benchmark? Well, the main reason is existing benchmarks like Flores, NTREX, and WMT and WAT don't have India-centric content. There is no test set for all 22 Indic languages. There are no modern use cases like conversations. The domain diversity is pretty bad. And the source diversity, as in the variations of source sentences, is also pretty bad. So that's why we decided to create the Indic 22 benchmarks consisting of Indic 22 Gen and Indic 1022 Conv. And Indic 22 Conv can be considered as a document level data set of sorts. So you can do document level machine translation evaluation with Indic 22 Conv. Just to give you an idea of the domain diversity, we have 13 different domains for both Indic 22 Gen and Indic 22 Con. And it covers stuff from education, culture, sports, religion, industry, governments, and so on. So it's very comprehensive, and it shows that our evaluation is not just centered on a single domain. How did we train Indic Trans 2? I'm not going to give you too much spiel over here because it's all here in the slides. You can go through it. But ours is a 1.1 billion parameter models. And we have separate models for Indic to English and English to Indic. By the way, Indic to Indic models will be released in a couple of days. So please look out for that. We are also going to release compressed models of around 200 million parameters, which are much faster, but don't lose that much performance. So please stay on the lookout. As for the model, it's very straightforward. Encoder, decoder, 18 layers. We convert all scripts to Devanagari as much as possible and then get them passed to the encoder and decoder. Our strategy for training Indic Trans 2 was multi-stage, where we had an auxiliary stage of training. First, we train on mine data and then on seed data. We use this auxiliary model to do back translation to get around 400 million bytext pairs for back translated bytext pairs. And then we do a second stage of training where we combine on a combination of mined and back translated data, and then a final stage of fine tuning on clean data, which is the seed data. So we have 4 stages of training and a huge amount of data generation. And the important thing to note over here is that this 4-stage training helped improve our performance step by step. How? If you look at this plot, you can see for different data sets and for different benchmarks, you can see what happens is, if you look at Flores 200 Indic English, you can see that the original auxiliary model stage 1 had a score of 57.7. This went up to 58.1. Then after back translation data incorporation, this went to 60.1. And then fine tuning on the seed data once again led to a score of 61.0. And this is more or less consistent across all the benchmarks that we evaluate on. What this means is that seed data is extremely important, and you should always consider fine-tuning on seed data or incorporating seed data during your training to make sure that you get the best possible performance. And when you compare against existing models like Azure and Google, which are, let's say, closed systems, and then we have our Indic Trans v2, and then the NLLB 54 billion parameter model, we can see that the Indic Trans 2 model is almost comparable, if not better, than most of the models. And why is this important is because Azure and Google are closed systems. We have no idea what's going on. They may have seen some of our sentences from the test set. So it's very hard to guarantee that these are clean evaluations on Azure and Google. But even then, our model, which we have ensured has not seen any of the evaluation data, it still does pretty well. So it's a very nice result. By the way, all these scores that I'm reporting are CHRF++, which we found to be very well correlated with human annotations for Indian languages evaluation. Now, in NLLB 54 billion parameter model is almost 54 times bigger than Indic Trans v2 and doesn't focus on Indic languages specifically. But even with the exploding number of parameters and data that they've used, we are still better than them or comparable with them. So it means that size is not everything. You have to narrow down your focus on a specific set of languages if you want to get the state-of-the-art results. So overall, we have Indic Trans 2 all the way on the right side. We have broken barriers for machine translation covering 22 scheduled languages. We have state-of-the-art performance in terms of CHRF++ as well as in COMET scores. And it is comparable, if not better, than models like NLB MOE and substantially better than previous existing models. We are now state-of-the-art for, I think, almost all of the languages. So now I hear now there is this buzz around using LLMs for Indic machine translation. So recently we started focusing on that topic. And we have 2 works accepted at EMNLP on this particular topic. So I'll cover them very briefly. So the first part is LLM prompting for machine translation, where I'll give you a bit of a background. So the idea is, suppose you have this Hindi sentence over here, which you wanted to translate. If you just simply give it to a LLM saying, hey, translate this sentence in English, it might not do a good job, because the LLMs, especially small LLMs, which are just LMs, they don't do a good job of zero-shot, what is called a zero-shot translation, which means translating right out of the box. But if you give it some conditioning examples, like a Hindi sentence and its English translation, and then ask it to generate translation for the given target test time sentence, then it does manage to do a good job. So typically what happens is, given a sentence, we retrieve some parallel sentences from an database. We construct a particular input in the form of a template, which is called as a prompt. We give this prompt to the LLM, and then we obtain an output. For machine translation is the translation, and then we compute a translation score, which is the comet or the blue score. Note that these retrieved sentences and this test set sentence has a number of metrics in terms of similarity scores, in terms of number of tokens, in terms of CHRF score, similarity with the retrieved sentence, blah, blah, blah. And most of the times, most works don't focus on these different, let's say, features. So in this work, what we wanted to do is leverage all features together in order to make a better selection of prompting examples. So rather than just select sentences randomly, or just use a single feature like overlap with the current test set sentence to retrieve an example, we want to retrieve examples keeping all the features in mind. So this resulted in what we call as the CTQ scorer, where we develop a scoring mechanism leveraging all the features of retrieved examples, and then learning a neural model which learns to rank the retrieved examples according to how well it thinks it will be useful for prompting. So, for example, over here, this English and Hindi and English sentence which has been retrieved, if the neural ranker gives it a low score, then we might not use it for prompting, because according to the model, it might not lead to the best possible score. So how does this happen? We first have to learn the re-ranker, right? So we have some held out example pairs, and we have an example database from which we retrieve the, let's say, translation pairs for prompting. So what we do is, for every, let's say, test sentence, we retrieve a bunch of examples via a very fast algorithm like BM25. It's an n-gram retrieval mechanism. What we do is then we extract a bunch of features like sentence length, we extract lapses similarity scores. You can check the paper for more details. And then we learn the CTQ scorer, which takes all of these features and learns a regression model. And what does this regression model do? It has to predict a score. What score does it predict? Well, we ask the model to predict a comet score of the translation. So essentially, the input is the features of retrieved pairs, and then the CTQ scorer has to predict what comet score are you going to get with this particular set of features. So if we have retrieved a sentence, and if the CTQ scorer predicts that this retrieved example will lead to a higher translation score or a higher comet score, then you should give this this example as higher priority for prompting. So during testing, it's very simple. We extract candidates or examples, we extract their features, we get them ranked by the CTQ scorer. Once we rank them, we sort them according to the rank or the score, and then we create the prompt, we feed it to the LLM, and we get the translation. What is very nice is we observe that compared to examples such as random selection or something like BM25, which will just use the n-grams for selecting examples, our CTQ scorer mechanism actually led to better scores compared to any of the previous models. Only focus on these Indic languages performance, because we saw lots of gains across Indic languages, not necessarily so for other languages. Just to drive the point once again, if you use a mechanism that takes the features of retrieved examples and predict the potential comet score because of these retrieved examples, then it means this retrieved example is a good example for prompting. And this has a lot of potential implications, because we are essentially learning how well a current example can lead to a better translation. So it's a kind of way of predicting the future or predicting potential performance. And this can also act as a kind of reward model, the CTQ scorer model. So now that we have the CTQ scorer model, we also had a parallel line of investigation where we considered relatedness between languages. So for example, consider the Hindi and Malayalam sentence, where the original sentence is boy eats apple. But if you look at the Hindi and Malayalam sentences, they're essentially identical in terms of their word order. And then there are fixed segments that monotonically align to each other. Now, I don't speak Malayalam, so I won't be able to pronounce these words. But what is observed is for most Indic languages, which are very similar to each other, the word ordering is almost monotonic when it comes to translation. So, and this monotonicity is often overlooked. So in our work, what we wanted to do is consider monotonicity as an additional factor when doing prompting-based machine translation. So we proposed what is called as DECO-MT, where we prompt MT5 independently then contextually. And how did we do this? So first we have, let's say, the source and target prompted examples. So we retrieve certain examples from a data set, from a database. And we have the prompt source, prompt target for 1 up to k pairs. And then we have the test set sentence, source sentence, which we want to get translated. Now, if we feed this to the MT5 model, note that it will not translate the entire sentence, but it will translate only a specific phrase from that sentence. So it will only translate one chunk. So we take that translated chunk and we append it to the input, and we ask the MT5 model to translate this partially completed translation. And so on and so forth, till at one point of time, we get the complete translation. So this way, you can incrementally build translations using the MT5 model. But this approach, we found, doesn't leverage any concept of monotonicity. So that is what we wanted to do. So we had 2 stages. One is you divide a sentence into chunks and translate each chunk individually. And then during a second stage, take these individually translated chunks to incrementally build the final translation. So what does this look like? If you look at the left-hand side, you have the sentence, the input sentence, divided into multiple chunks. You use this MT5 prompting approach to translate only that chunk and nothing else. You don't translate the whole sentence, but that's just that chunk, because MT5 is good at chunk-based translation. Then what we do is take these individually translated chunks and then use this as some kind of contextual information to update a translation. So you take, let's say, the first 2 source sentence chunks, you have a mask token in the middle, and then you have the target sentence, the predicted chunk for the second chunk. And what we do is we ask the model to predict what would be generated for this masked chunk, and it generates R1. So now you have, for the next step, you have the 3 source sentence chunks. You have the first predicted chunk. Then you have the previously independently translated chunk for the third segment. And then in the intermediate corresponding to H2, there is a masked chunk. And we asked the model to predict what would happen, what would be the translation of this masked chunk. So we use M1 to M beta to improve, to generate improved R1 to R beta, which then concatenated would lead to the best possible translation. So why is this very important? Is because we are leveraging the monotonicity between chunks. And on the right side, you can see a certain example of how we have a template for translation from Hindi to Malayalam. We first translate the Hindi sentences like Kalan ki Rajghani, and then we have the Malayalam chunk, which is independently translated. And then contextually, we take the Hindi and partially translated Malayalam chunks and construct the final translation one step at a time. And once again, looking at the results, we see that compared to what is called as the SAP, or called as the structured a priori prediction, which does not use this chunking or 2-stage approach, our DECO-MT approach gives significantly better performance for related languages like Hindi Malayalam, Hindi Marathi, Hindi Gujarati, and Hindi Telugu, as measured in terms of CHRF++ score. So this monotonic chunk translation and then leveraging these chunks to construct the final translation reduces the load on the model for generating high quality translations. And then this can obtain essentially a translation between related languages with a very high quality. On the right side, we did some human evaluation and we found out that compared to standard prompting and structured a priori prediction, our DECO-MT or decomposed machine translation approach with MT5 gives better human quality. So yes, this is a very nice approach, and you can leverage monotonicity. And the lesson to take over here is please use monotonicity wherever possible. So now I'll quickly cover evaluation, which is the last part. Now we use a lot of metrics, right? We use BLUE, we use CHRF, we use WER, TER, blah, blah, blah. But which metric is good? We don't know that. So in one of our works for MT evaluation, we focused on determining for Indic languages translation, which is the best possible metric. So this is known as meta evaluation of metrics. And what we try to do is we have a human annotated data set where the humans tell how good this translation is. And then we try to make a correlation between the metric score and the human annotations. So what we did is in our ACL paper called Indic MT Eval, we took a bunch of metrics such as BLUE, CHRF, Rouge, then some embedding based metrics, laser, LabSe based embedding metrics. We took MBird, we took Indic bird based embedding representations to determine quality. And we also took the Comet QE and Comet DA and Comet MQM models, which are trained or let's say neural supervised models for evaluation. We created a lot of data for, let's say, 5 Indian languages, where we translated sentences from English to these Indic languages and asked annotators to tell us how good these translations are. And essentially, what we did is then computed CHRF scores or whatever scores and determined the correlation between the human annotations of how good this translation is and the CHR and the whatever scores we have. And we can see that when it comes to automatic metrics, CHRF scores tend to give the best possible correlations with the human annotations. So this is the reason why I've been reporting all the scores in CHRF++ so far, because it is highly correlated with human annotations. But of course, if you want to compare against, let's say, the best possible scores, then you will see that these neural scores or Comet models, they tend to give the highest possible correlations. So comparing between CHRF, which had a highest correlation score of 0.348, neural scores such as Comet models, scorers such as Comet models, they gave correlation scores of 0.557. So it means try to use supervised metrics if possible, but you might want to train them. And how would that happen? First, the important thing is how you would collect data. You have, let's say, outputs of system translations. You give the bilingual expert annotators. You ask them to annotate any score, any errors, or any missing translations, or any bad parts of the translations. And this leads to what is called as an MQM score or an MQM annotation. And this MQM annotation is then used to compute what is called as a score for the translation. So every single time the annotator says, okay, there is an error, we deduct a score from a maximum of 25. And then the final score will be after all of these deductions. And once we have that, we have a number to predict. And this can be trained by any kind of, let's say, pre-trained model. So we did exactly that. Using all the annotations for different languages, we trained what we call as Indic Comet. So what we did is we took the Comet MQM model and fine-tuned it on the MQM annotated data that we had. And we got the Indic Comet model. And this Indic Comet model, if you look at all the way on the right side, it had higher correlation scores with the human annotations as compared to Comet MQM. And the main reason for that is because now we have made the model see Indic languages data, which is a very nice thing. So in other words, if you have the capacity to do human annotations of, let's say, evaluations, then you can get these human annotations, represent them in some score, and then fine-tune existing models to get a reliable metric for evaluation. And Comet is what most people are using, and therefore I strongly recommend collecting a lot of such annotations. So in summary, I talked about the Indic BART and Indic NLG benchmark, where I showed that language family specific models are crucial. I talked about Indic Trans 2, which supports 22 scheduled languages with language family focused efforts. I talked about Indic MT using LLMs, where we focused on neural models for feature combination for re-ranking, and then how to leverage monotonicity to improve translation between related language pairs. I talked about Indic MT eval, where the main lesson is to choose your metrics wisely and to make Indic Comet a reality, which could also be Odia Comet if you can collect annotation data for Odia. And then finally, there is future work such as focusing on more Indic languages. There should be focus on data sets, tasks. Indic LLM is something that there's been a buzzword that people have been talking about it quite a bit, but I suppose it will come out at some point of time. And then, of course, robust evaluation, because without evaluation, none of our models mean anything. Our evaluation should reliably indicate whether our models are actually doing well or not. I would also like to thank all of my contributors and collaborators from AI for Bharat. And none of this would have been possible without the support of many dozens of people. So I'd like to thank all of them. And with that, my talk is at an end. I'm happy to take any questions.
I have a question. Hello, Raj. Swateek.
Yeah, hi.
So you mentioned the 22 languages which India has.
Yes.
If I were to pick the lowest of low resource language,
Yes.
which has no data set, and let's say that someone who is speaking that language is interested, which language is it, and where should they start?
So by the way, there is no language which has been left behind. We have parallel data for all languages. We have seed data. So we have constructed seed data for all 22 languages. So it is not the case that there is any language which has no data at all.
Okay.
But that being said, if you're talking about data which has the least amount of mine data, I would say it has to be something like Kashmiri, Bodo, Dogri, the tail end languages. Santali is extremely low resource in this case. So we typically observe low translation scores for these languages. But still, according to human annotations, they were not bad given the resources that we had.
So how would someone, let's take, for example, Santali.
Yes.
How would someone go about like creating a data set for it?
Right. So creating a data set, I haven't covered this because of lack of time, but what we did is, so there is a huge, let's say, process. We start out with selecting our sources. So you'd first look at the web, you'd look at Wikipedia, you'd look at some news articles, you'd look at different domains, and then you'd select your source sentences, which you think are representative of that particular domain. Then once you've made sure that these sentences are clean, very good quality, representative, and diverse in terms of their content, you would have them translated by annotators. You can use Indic Trans to get an initial translation and then get them fixed by annotators. But we found that this might induce biases from the machine translation system itself, because post-editing versus raw translation has different implications. So I would say that get them translated. And this can be an incremental thing. This involves a lot of time, a lot of volunteering effort, and a lot of, let's say, money as well.
True. Well, thank you so much. I have a question. I think Malay has raised his hand. Malay, please go ahead.
Yeah. So first of all, thank you, Raj. This session was much needed. So I have a very quick question. So all these translations which are happening, are these happening a single model at a time, or we can also do the interchanging? So for suppose if there is a learning happening between suppose English to Hindi, and there is another learning which happened with English to Marathi. So is there any way possible that we could also do the translation, like without learning, we could also do the translation between the other two language pairs? Like suppose Marathi.
So you're talking about zero-shot translation, am I right?
Yeah, sort of, but I'm just asking, like, so for suppose the model has, because already learned the you can say what do you say, the pool of the languages. So is it able to also correlate between the other two pairs, if not like specifically told? So yeah, maybe zero shot.
Right. So yeah, you're talking about zero shot, and yes, these models do have sufficient zero shot capabilities. So again, I didn't mention it in these slides, but in the Indic Trans 2 paper, what we did is we evaluated on certain dialects like Awadhi and I forgot one more dialect. but these dialects are present, let's say, in the Flores 200 benchmark. And when we evaluated on these dialects, the data for which was never seen, we actually did get some zero-shot performance for them, and it was not that bad. So yes, coincidentally, these models do learn correlations between unseen directions, and that is the whole story behind zero-shotting. And also, I might have mentioned in my Indic BART work, where although during fine-tuning, the model didn't see certain language directions, but because of pre-training, the model was able to handle translations for those directions. So yes, it does happen.
Also, just one quick question. So, for suppose if some translation is happening between language A to B, so is it also possible that without further training the model, we can also do the translation between B to A? So, is it also zero-shot thing, or is it something else?
So, if your model has been trained from A to B, the reverse direction, it's not going to happen. So, unless there is a way for B to go to A through some third language, I doubt it will happen.
Okay, just to know why, because I think the model has.
Maybe there are some other questions, Malay. If you let other people ask questions also.
Sure.
Yeah. Did somebody ask? Was someone trying to ask a question? Okay, then yeah, Malay, you can continue your question.
Yeah, sorry, Malay can continue.
Yeah, so I was just asking, like, why is it like, I know, like, maybe it's not possible, but because the model has already seen both of the languages, like one has been learned through encoder and another has been learned through decoder. So if these two are the same parts, like just the reverse process needs to be happen. So why can't we develop a architecture which can do this reverse process?
If you're most welcome to invent such a thing, but just
I'm just
you can't reverse. So the encoder and decoder are non-reversible as far as I know. The encoder's job is to create, let's say language agnostic representation, and the decoder's job is to transform this into a target language. But if you wanted, you could always invent something called as an invertible transformer. So you can give stuff as input to the decoder, simply swap and get output from the encoder. I just cannot visualize such a thing in my head right now.
Okay, yeah. Thank you, Raj. Thank you.
You're welcome.
Thanks, Malay. We have another raised hand from Sujit Cheswal. Sujit, please go ahead.
Yes, Raj, I had one doubt about the metric thing.
Yes.
Like SARS Blue wasn't the CHRF++ is giving better result than the SARS Blue. Is it because of the free?
Are you talking about Sacre Blue?
No, SARS Blue. We were focusing more on CHRF metric.
Yes.
As compared to SARS Blue.
What is
Sacre? It's the Sacre Blue you're talking.
Are you talking about Sacre Blue or SARS Blue? Because I don't see
Sacre
SARS
Blue.
Blue.
Sorry, Sacre Blue. Is it because of the free word order of the Indian languages?
That is our hypothesis, yes.
Okay.
Yes.
Okay, thank you.
So also, Indian languages are more morphologically richer compared to, let's say, analytic languages like English. And therefore, when you have morphologically richer languages and when there is free word order, even though translation might be correct, you might end up penalizing translation that looks correct just because it doesn't have the same word order, the same inflection. So that's why, CHRF++ appears to have a better correlation, at least according to our investigations.
Okay, sir. Thank you.
Thank you. Thank you so much, Raj. Of course, you're continuing with us with another QA sessions. We'll take those, whatever questions you have, please drop into the chat box. We'll take these further questions in the next session itself. That is a good segue for our next session. Welcome to this session where we get to pick the brains of some of the brightest minds, the fast and growing fields of artificial intelligence. And we at OdiaGenerativeAI are thrilled to have with us Dr. Raj Dabre and Dr. Swaroop Mishra with us, who have joined from across time zones. So Dr. Raj has been introduced to us before. We thank him for his patience for doing back-to-back sessions. The passion with which he presented his Indic language journey is infectious, and I hope it has inspired quite a few of us today. Thank you, Raj. And also we have Dr. Swaroop Mishra, a research scientist at Google DeepMind, where he works on BARD and other AI products. His key research contributions are instruction tuning, various prompt engineering techniques like reframing, question decomposition, program representation to improve mathematical reasoning and instruction bias. So he's received the ASU 2023 Dean's Dissertation Award and CEN/CS PhD Outstanding Student Award. So to our guest, we have questions from you that has been crowdsourced from everyone, some of which will flow in as we are speaking as well. So I'll pick them up and present to you before we get started with the questions. Please tell us a bit about yourself and what keeps you motivated in doing what you do. We'll start with you, Raj.
So I think there was already a very kind introduction done. So you know about my educational background and what I've been doing. But what keeps me motivated is just the fact that I find this interesting. This all started about like a decade ago. I went to IIT Bombay for my interview for the MTech RA program. And at that point of time, I was thinking of doing computer vision or like say image segmentation for maybe whatever the next few years. And then I just coincidentally happened to hear a talk by Professor Pushpak Bhattacharya from IIT Bombay. And he started talking about like, hey, you know that you can translate from one language to another. And as someone who hated studying Marathi, English, like languages during school, for me, it was like, can you really do this? This is a game changer. So I got in over there and I've been hooked since then. Then from then, my interest in languages only grew. And that's what keeps me motivated. For me, it's like every single time people solve a problem, another problem pops up. Like last year, ChatGPT came up and everybody was like, okay, problems have been solved, NLP has been solved, but that's not true. It's just another thing, can of worms that it has opened. So it keeps me going that there's always some new interesting problem that pops up.
That's quite good to hear. Swaroop, are you available for us? You could
Hello.
unmute. Hi.
Can you hear me?
Yes, and we can see you as well. Thank you so much.
All right. Yeah. Thank you very much for the invitation. So yeah, I'm very much quite passionate about initially in my early days into physics and maths. And that led me towards how can model different physical process and natural phenomena towards machine learning, which basically is sort of black box modeling and all sorts of things. So I started as a theoretical machine learning in the beginning, more interested in basic like backpropagation, architecture, like those kind of stuff. Slowly got into applied stuff, NLP, and more recently in instruction tuning, large language models, how to train large scale models, and yeah, various aspects of how to get the best out of language models. And yeah, that's pretty much what I'm excited about.
Well, thank you. This is not like ABC, but I'll be reading off my computer screen. I have a question from Suhas. His question is to Raj. It says, to build a model specialized for a new language like Telugu, do we have to train a model from scratch?
No, not necessarily. If you already have a pre-trained model. So for example, we created Indic Trans 2 for that very reason. We created Indic BART for that very reason, so that you don't have to train anything from scratch. And you don't need that much of data either. You can just take some data for refining for that specific domain, for that specific niche that you're working on, and just fine tune it. You can solve the problem in a matter of hours rather than a matter of days or weeks now.
He does have a follow-up. So we have asked two questions. So as you mentioned Indic BART, he says that if a pre-trained model is better, how do we choose which model is better to learn a new language?
When you say which pre-trained model to choose,
yes.
Right? So I cannot give you a very concrete answer on that, but I would say that it's a matter of choice, right? So for example, if you're focusing on Indic languages, the odds that pre-trained models specialized for Indic languages will have more Indic specific content will be nicer. I'll tell you why. Because you see, the English news that is present in India is Indic context English news, whereas the English news that is present in BBC might not be English context. So that's why you'll always see differences between the content present in something that is produced in India itself, even if it is English, and content that is produced outside of India. So if you see a model that has that has a chance of having more relevant content, so you should always look at what the pre-training data was, what the training data was. And you should try to compare between the downstream tasks that you have in mind and whether this pre-trained model might have that kind of content. And that is going to give you a higher chance of getting better performance.
Lovely. Thank you so much. Swaroop, the first question that we have is, could you elaborate on the, let's say the first question is, how would you explain instruction tuning to a layman?
Hmm. Okay, great question.
That was my
So,
question.
yeah, sure. Um, See, like we know in basic machine learning, we learn from data, right? Like what is data? It's a bunch of input and output pairs. And we try to learn a function f that basically maps between input and output, right? Um, and we require a lot of data to learn, like thousands of data, millions of data to learn a task, right? But if you think of humans, right, it's not just from examples. So data is like an example. You look at somebody, you try to imitate and all those things. But you also learn from interactions. People tell you something, your parent tell you something, your friend tell you something, you learn from that, like sort of an instruction. And if you say in typical machine learning, right, how data comes, many times data is natural, but many times data is created, like say crowdsourcing or by some data creator create the data, right? And how they create the data, they write some instruction. Okay, this is my task, they define it. And then they hired some crowd workers, say from Amazon Mechanical Turk or many places, who basically follow the instruction to create the data set, like a bunch of input and output pairs. And now what happens, what used to happen, right, until very recently is once the data set is created, you just learn from that. Like you throw away the instruction. I mean, those are the instructions that actually help the crowd workers in producing a large scale, reliable data set, right? It's a rich content. If you see people who have spent like time in creating data sets, a lot of effort going to writing the instruction because it can create bias and all those things. So it is, but we don't use that in learning a task. Just learn from data because traditionally machine learning has been data driven. That's data science. But this is a rich content instruction which we throw away. So can we use it? Why to throw away? Because it's helpful. It's helpful for humans. It can also be helpful for machines. That's how the instruction tuning come into picture. But the beauty of it is actually the inference time, zero shot learning. So in traditional machine learning, what happens is if you train a task, say to do it will if you do whatever task you train, model can do that only at test time. If you train on n task, model can do n task, right? But clearly, it's very difficult to estimate what kind of task people are going to use, like say ChatGPT, Bard, or any of these models, right? People will use random tasks, which are even very difficult to estimate, right? I mean, and they might not be, I mean, they might not have the resource and knowledge to create data set to teach a task to a model. They can just describe in natural language, like what they want, like say, make a diagram or, any kind of random task.
Sure.
So to be able to happen, model need to learn a task directly from instruction and do not require data and training, because training also takes time. Back processing has to happen, fine tuning, it takes time. There's no time. Everything has to happen zero shot. People describe it in natural language. So both this thing, both for training time as well as what you see right now, the conversational behavior of zero shot learning of these language models is actually coming from this instruction tuning. So that's very simple. Yeah, without going to, yeah.
Well, thank you for being elaborate. It's quite nice. I do have another which goes into deeper water, and this I have to elaborate on the algorithmic intricacies of instruction tuning in contrast to fine tuning in large language model. So
yeah. So basically, it's so there are different variants of that, but I'll tell you the basic one is we change the encoding. By encoding, we mean previously we used to feed only the input and output. Here, along with the input, we have instruction that accompanies the input, and that's the change in the training time. And the difference is, so basically similar to multitask learning, that we have n task. We try to learn from all multiple tasks and help the model generalize to one same task. But along with input, we have instruction, and that actually produces some sort of inductive bias, and model tries to learn compositions. Like you don't have, because it's very difficult to cover all possible tasks, right? But if you, since the task is accompanied instruction, if you see an unseen task, you might have the unseen task, say 30% similarity with the turning task A, 20% turning task B, and you can compose over that and try to come up with try to solve the new task. So algorithmically, it's all about encoding. Yeah.
nice. So short. Raj, the next question is for you. And this is from our interns who have collected the questions. So in what way current large language model addressing the linguistic nuances and script diversity, which is inherent to Indic languages? Things that you have touched upon, but I'll repeat the question for you. In what ways are the current large language model addressing the linguistic nuances and script diversity that is inherent to Indic languages? There were questions around dialects and languages, right? So on same lines.
Okay, so I can say that most of our models that exist, they barely can handle, let's say, large amount of linguistic diversity. So, for example, most models would really not do a good job at code switching. Most models cannot handle dialects. Dialects, they can handle them, but the performance or the translation quality or the generation quality in dialects is not as much. I don't know how well ChatGPT does or GPT-4 does, but I can say that Indic Trans 2 or any of the models that I've used so far, they're not that very good at dialects. That being said, there is an interesting, let's say, segue I'd like to make is on the topic of creoles, which I work on quite heavily. Creoles are like languages which are the result of colonization. So essentially, if you see that France used to take slaves from India and then take them to places like Mauritius, and then these were people from different countries. They had to learn the language of their masters at that point of time, but then they used to mix it with certain of their own local languages. They initially communicated by pidgin, and then when a pidgin is acquired by let's say a native speaker, that becomes a creole. So again, the support for creoles is very terrible. Although MT system might be able to deal with French language very easily, it cannot handle French-based creoles at all. So I would say that the nuances in terms of diversity of languages that models can handle is not as much as we would like it to be. It is getting better compared to, let's say, when I first worked on Indic BART, because now there is interest in dialects, but not as much as we would like to. There is a paper that I can point out, which is co-authored by Anup Kunskutan, which is on how to manipulate vocabulary to handle dialects. I would say that is one interesting work which kind of points on how to handle dialects without any kind of training data. So that is one thing. When it talks about more deeper linguistic nuances, maybe some cultural things specific to that particular language, I don't think there has been any holistic evaluation of those specific aspects. So that's also missing. And then I was going to just talk about one more thing. Linguistic nuances, cultural references. No, that's about it. So I would say we still have a long way to go. By the way, you're muted, and I would also like Swaroop's opinions on the same. Let's not just be one for one. Maybe have everyone chime into these things as well.
Swaroop, do you want to take the question?
No, I think he already explained it well. Yeah, that's fine. Thanks,
Okay.
Raj.
I do have a follow-up, Raj. So if someone were to start text-to-speech application on this, or model on that, so where would someone start with? For example, in Odia, we have multiple dialects. Like the state is one, but there are multiple dialects which people speak in different parts of the state. That's true for the entire country that we are in. So how is it, where do we have the starting ground for text-to-speech in dialects when we want to talk about dialects? Where do we start?
Right. So the main starting point is have a good text-to-speech for standard spoken Odia. If you don't have a base model for standard Odia, you aren't going to get very far with any of the dialects. So I'd actually like to know, I don't know what is the state of the art for Odia spoken language generation. Can you tell me about that?
Odia spoken language, the one that OdiaGenerativeAI has, that's the standard language. We haven't gone into any dialect for now.
Okay.
But yes. But
okay. So I would say first boost the amount of data that you have. Because it should be easier for you to collect standard spoken Odia as compared to dialectical Odia. You can go to YouTube, you can go to a bunch of copyrighted stuff, and that's going to involve a lot of annoyances with copyright, but at least that's a source of data. YouTube data is one source of data. You could probably scrub the data, get some, let's say, transcripts, and you can also get the spoken content. You can also pre-train on the spoken content like Wave 2X. You can get a lot of audio data and pre-train on that. And then once you have that, I would say do groundwork. So I can tell you in AI for Bharat, one of the things that they did is they traveled to all the major districts all across India. They sent the actual researchers and some of the linguists to collect audio samples of a variety of dialects of a variety of languages. This involves money, this involves funding, no doubt. But I would say that some crowdsourcing effort, some serious amount of crowdsourcing effort is needed. And I can make it more encouraging, because you can see that I say over the past 1 year, you guys have come up with this OdiaGenerativeAI group, which didn't exist on the map at all maybe a year before. So I would say if in a year you are able to bring together so many people, I'm sure all of these people who speak their individual dialects can maybe put in some efforts. Maybe there is someone in your neighborhood who you can just, hey, like, do you want to speak into this mic and give us some data? Speak in your dialect, get some audio samples. I would say that's a nice starting point.
Well, I thank you. That was helpful. And I have a question from Pravir Kumar Sau. It's a general question around how important is cybersecurity in generative AI, and what steps do you take to ensure that to protect your to protect your IP rights, to protect everything that you have. And of course, this is questions for both. You have to go.
I'd like Swaroop to speak first, and then I'll speak later.
Perfect.
Yeah, great question. So this is basically, a sort of a dilemma, because the next big thing is coming on the personalization aspect. How can you have a personalized AI for us? And when you want to build a personalized AI, you want, the model to know your preferences, the things you like, and share across. Like, say, talking about Google, like what YouTube videos do you watch? How do you preference in Gmail? What Google search you do? And everything to be integrated to one chatbot, and those kind of things coming. That means that on one hand, we need those kind of personal data to be able to provide you best suggestions. I don't need to tell the chatbot again and again that I live in this area, or I have a kid or whatever, right? It need to know that. It need to have a memory, right? That means we need those kind of information to be able to provide the best, across product, the best suggestions. But at the same time, like you said, the security aspects, data leakage, and all those things are very important. But that's why the trust come into picture. Like the companies, like who have built trust over the years in protecting user privacy and all those things. So I think what this is going to be very important going forward in future, because this data will be required to customize a chatbot or customize a LLM. But yeah, we need to follow the standard protocols to make sure they're secure and all those things.
Thank you, Swaroop. Raj,
I'd like to add to that. So I think the general research area, which I don't work in, by the way, is called differential privacy. And what it involves is making sure that whatever LLMs you produce should not regurgitate anyone's private data. So if I ever give my own data to, let's say, some LLM training, then no one should be able to use that LLM to start getting facts about me. And people have done adversarial attacks in the past. There have been a couple of papers, actually more than a couple of papers, which have shown that if you prompt these models in a specific way, you can get them to regurgitate this kind of data. So people do have securities on top of this. So they have some secure algorithms. There are algorithms where let's say, names and personal information is masked out, or this names and personal information is maybe converted into something that is not relevant to a particular user. So of course, if you're putting out a language model out to the public, you should try to make sure that nobody's private information is included. And if it is, the model should not be spitting it out very readily. And there are some differential privacy preserving mechanisms that people have used. Again, these are just terms that I know of. I'm not an expert in this. And the second part is, as Swaroop mentioned, the personalization aspect. We want personalization, but we don't want someone else to get our personalization information. So there is a balance that needs to be taken, and how well a model will respond to that, I mean, it's still an open area of investigation.
So do you think it's this question follow-up anyway for both of you? So do you think it's the onus on developers who are working on this, or is it like a third party who will ensure that, hey, our data should not go out? Or is it a collective effort?
I think it has to be an interaction between both.
I'll just add one more point that this thing actually is taken very seriously. There are dedicated teams working on this, especially for ensuring that that there is the jailbreaks and all the security things are taken into consideration. People take it very seriously. Companies take it very seriously. It's not a normal thing. Yes. So maybe if somebody wants to do research, probably that's a good area to work on. That's going to be important going forward in future.
Yeah. Right. The question was exactly around that, and yes.
I want to add one more point to what Swaroop said. Companies taking this very seriously. I can also tell you that although NICT is not a very large corporation, we have strict rules around handling personal data. We have to make sure that any data we put out, that the personal information is completely scrubbed. So either we guarantee that there is no personal data, and if there is accidentally something, that the creator of the data gets punished, or we don't put out the data at all. So there is a huge amount of it's a huge topic, even in Japan.
Right. I mean, I understand that with the advancement of AI, the way it is going in, we really have to be sensitive around these areas, something that we probably didn't take seriously 7 to 12 years back. All right. That was great. And I have a very interesting question from Sai Teja, especially I would want Swaroop to go first on this. It's a basic generative AI question. So he says, how to generate poetry in native language like a style transfer way. And his example is poetry on Lord Jagannath by different poets in different style. Is it possible to generate in similar style? It's a plain generative AI question, not related to your field, but please go ahead.
If you want that, I mean, I would take that as a prompting challenge. Can we do that? That would be a good challenge. So I'm not specifically sure about the specific Odia language question. I'm not worked on that. My area is mostly on general NLP, but I can imagine various way of to prompt the model to basically, first of all, maybe generate a poem first, like this decomposition based prompting, something like that. Generate a poem first, generate a poetry first, and then convert it to a specific style, and then give some example of Jagannath style and do it step by step. I don't think it's too hard for the current models, but yeah, I would like to do in a recursive prompting way.
It doesn't have to be very specific to this. I was saying, let's say someone wants to write the Kabir Ke Dohe style. So how would they go about it? Is it possible in the current situation? So let's look at the question in this way.
So it depends, right? Like, you want to use the large scale models, or you want to build your own model, right? So what kind of preference? If you have resources, you want to fine tuning open source model, yes, you can do that. But I was talking more in terms of using Bard or ChatGPT, the existing LLMs, and how to prompt them to get what you want. But if you want, which I already answered using prompting, but if you want to do a fine tune a Llama 2 or something like that, I would actually go with the standard protocol of instruction tuning, in the sense that, like, we did that in self-instruct. Basically, create a small seed data, like say small examples, create by hand, and then try to sort of expand it. Basically, say maybe create 100 examples and expand it to like 10,000 or so recursively, and instruction tune a model. And
that's a good thought.
Yeah.
Raj, do you want to add something to this, since you are a Indic language expert?
So I can tell you that last year, when ChatGPT was launched, in the Slack group in AI for Bharat, people were going crazy trying these things, actually, these very specific things. So for example, they tried to get the certain poems, but rewritten as a rap by Eminem, for example. And as Swaroop said, it's actually not that difficult to get these instruction fine-tuned models do these things. I think it's a matter of what data your model has seen, and what it's a question of scale. It's a question of the data. These two things determine how well your model will be able to do these things. Apart from that, I think there are some nuances here and there about model being able to do this specific, how to prompt, how to condition, as Swaroop said. But to me, it looks like more of a creative writing use case, which I think these ChatGPT-like models are able to already do pretty fairly well.
Great. Well, thank you. Swaroop, next question for you is around, how does instruction tuning impact the trade-off between model generalizability and specialization, particularly in domain-specific applications?
This is all about generalization. Machine learning is all about generalization. No?
Exactly. Now that we have
So, specifically, I think, which I mentioned at the beginning, the whole point is it's very difficult to estimate what the user are going to use the model. Like Raj gave an example, right? People trying crazy things like a poem convert it to somebody's style, or you you ask a question. I mean, there are so many possibilities, right? So you need generalization. You can't know this beforehand to train a model, right? And that's the beauty of instruction tuning. That, I mean, if instruction tuning is completely successful, theoretically, any task expressed in instructions by natural language model should be able to do it. Of course, it's not always 100% successful. So there is this trade-off. But the whole goal of instruction tuning is to, like there's a AGI, general purpose models, and generalization is at the heart of the motivation behind instruction tuning.
Thank you. Raj, I have a question for you, and it is, how does handling of code switching and mixed language contexts in Indic NLP pose unique challenges and opportunities for the language model development?
So actually, you're opening a can of worms by asking this question. But I can tell you that thus far, there is no reliable benchmark for code mix translation evaluation. Last year in AMNLP, there was a shared task for code mix translation evaluation. And they had given us some English to English task, and they had given us some parallel data. I don't know if any of those creators are in this chat room right now, but I can tell you that data is really bad. There is almost no reliable benchmark. So first of all, our primary efforts, and most of the efforts initially, will go around proper benchmark creation and data creation. Data collection is possible because Twitter does have a lot of code mixed text. In fact, I can point you to this resource called as, I forgot, but there's this group called L3 Cube in Pune, which collects a lot of linguistic data for Marathi, and they collected a lot of Minglish and English code mix data from Twitter. In fact, they collected, which to my surprise, around 40 million tweets, 4 or 40 million, but a lot of tweets for English and Minglish, which to me is already huge enough. But what if we could get some of that data and get it translated? And I think code mixing is specifically used mainly in social media and conversations. So it's a very good opportunity for working on conversational AI, conversational systems. Start out with the data, collect data. We have to put together benchmarks. And once we have benchmarks, right, and as Swaroop mentioned, you work with a small amount of seed data, and you can incrementally synthesize a lot more data, and models should be able to handle that in multiple iterations. But again, I'm very insistent on evaluation. I think if evaluation data is bad, if your evaluation metrics are bad, then you're not going to be able to do anything. So that also means that you can have a code mixed Indic comet, for example. So there is scope for work over there as well.
Right. I have now we actually the group that we have right now is a lot of people who are in academics. So if Raj and Swaroop, questions to both of you, like if you were to take a fellow researcher or a colleague in your team, right, what would you expect them, what qualities do you expect them to have? I mean, and what you would expect them to deliver? Let's say in this era, this is 2023, 2024, let's say. So what do you expect from it? Raj, go first.
Hands-on. You have to be hands-on. So anyone who is hesitant to, let's say, get their hands dirty. So if I tell them like, hey, I want you to first of all study Indic Trans 2 or Indic Bar, they have to be willing to get to the basics of it, get this model running on some notebook or whatever it is. If compute is a problem, I'll be able to help them with the compute. That's not an issue. But be hands-on. You should be able to play around with the model. So this takes me back again to 2011 to 2014. With Pushpak Bhattacharya, where he used to have something called as NLP gym. So essentially, normally when we go to the gym to work out our muscles, he used to say, take these models and work out with these models. See what they're doing. Without actually playing with the models, you'll never know what these models can and cannot do. And this gymming thing is something students should be willing to undertake. Because if you don't know what the model does, you can't solve the problems. You won't know what problems exist. So that is one thing. Second thing is tenacity. That you have to be unwilling to give up. Of course, sometimes you have to give up. That makes sense. That's a failure, and you have to learn from failure. But tenacity, you cannot be like, okay, mere se nahi ho raha hai, I cannot do this, so I'm giving up. It shouldn't be like that. And the third thing is that they should be willing to read a lot of papers, because papers are where the knowledge comes from. I can tell you that there are months I go where I don't read papers at all because I'm busy with the hands-on implementation stuff, and months where I have a lot of time to read papers. And I feel a lot smarter when I read papers, and I'll have a lot more ideas when I read papers. So Those are the three things that I would expect.
Nice. Swaroop.
Yeah, sure. I think, yeah, plus point to what Raj said. To add more, the engineering skill is underappreciated. A lot of this LLM work, I mean, even in instruction tuning and fine tuning large models, we get into all sorts of troubles. So we need to be a good software engineer first to be able to handle and really debugging, troubleshooting. It happens all the time. It goes unnoticed. First of all, that a good researcher need a good engineering skill also. The second thing is, especially for the type of work, like we see in daily life, we want people to be bit brave, and be able to take risk, not be afraid, not to settle down, because that the challenge is basically new every day. Like hallucination is a big problem, like security usage is a big problem, and new problems keep on coming. Personalization is a big problem. And like you are the leader in the field, like you have to do it yourself. So yeah, I mean, people who are not afraid of taking risk and open to explore, ready to fail, and yeah, good at engineering, there's more skills, I think. Yeah, very important.
Lovely. I really hope you find a lot of people from the small community that Dr. Shantipriya has created. I have a question from Devashish, and it says, are there any precautions that you need to take when pre-training or fine-tuning a model on multiple languages? Sorry. Are there any precautions that we need to take when pre-training or fine-tuning on a model on multiple languages? Raj, do you want to go ahead?
I would like to understand what precautions they're implying, because there are a number of precautions that you need to take, including if you don't have the budget for it, you should probably avoid doing pre-training, because these are very compute intensive tasks, and you can only do this one shot most of the times. But what precautions are they implying? I would like to know that first.
I don't have any further context, but possibly to enhance the model output so that it's more in line with what they want.
Okay. There is
that.
one precaution: data. Make sure your data is clean and representative of the various things you expect to fine tune it on. So I would say that you have to be very careful with your data. Make sure it represents what it is that you want to work on. The other thing is do a lot of small, basic, let's say, ablation experiments. Let's say if you want to pre-train your model on, let's say, 7 billion parameter model or 1 billion. It would be easier for you to do some initial ablation experiments on, let's say, 200 million parameters, and not completely, maybe just train for a few case steps, just to see what the general trends look like. And then you can try to extrapolate what it might look like in larger scales. Now, note that this is not something that you might be able to always extrapolate, because not all scale laws apply all the time, especially when you bring multilingualism into the mix. There is one paper that I would strongly recommend everybody reads. It's the Gopher and the Chinchilla paper. Especially the Chinchilla paper tells you about these scaling laws, about what are the number of tokens you require. Always make sure that you're training compute optimal models. Don't just throw your data at any model and expect, okay, I have only 100 million points, but I have like a 10 billion parameter model, and therefore I'll get state of the art just because I'm using more parameters. It doesn't work like that. So do your background research a lot more. That's the only precaution I would give you at this stage.
Lovely. Swaroop, do you want to go ahead?
Yeah, just to add, like, I mean, it's like you have to really judge. Do you really need to pre-train a model? I mean, existing models are really good. And do you have enough data, enough compute to really do pre-training? If it's an alignment problem, go for fine-tuning, clean data. But take your decision. Like, I think the open source models and even the APIs and all those things are pretty powerful. And don't do it because you just have to do a pre-training. I mean, do it only if you need it. And data quality is, I mean, it's very important. Yeah. So,
and fine tuning is the way to go, is what you're saying, that for a particular task to be achieved.
Yeah, but how do you do fine tuning also matters, right? Like, I mean, how did you want to do instruction tuning? You want to do RLHF? You want to do regular fine tuning? So, multiple options. So.
All right. So there are a few questions which are floating in right now. Folks who are raising hands, I would. Okay. I have a question from Upendra Kumar Jena. People who are raising hands, could you please drop your questions in the chat box? I'll pick them up from there. So Upendra Kumar Jena has a question, which is, while working on conversational AI chatbots, while the database is of some language, the queries can be of diverse languages. what architecture would you suggest, like translator pipeline, or rely on the model capability or prompting to handle this, considering the current LLMs available? So the question is around what architecture would you suggest, like translator pipeline or rely on the model capability or prompting to handle, considering the LLMs available? Please go ahead, please.
I hope you don't mind if I answer first. So if your LLM is English only, there's no way it will be able to handle any other language. So the translator pipeline is the only solution that you're going to have. But if you have a multilingual LLM which can handle multiple languages, then there is actually a paper which came out just last week which talks about solving problems via translation. So what it does is it instruction fine-tunes an LLM to first translate from one language into English, solve the problem in English, and then translate it back into the original language. Okay. So this means it's a kind of a multi-sourcing and a pivot kind of a solution, where the translation capabilities are incorporated into the LLM via instruction fine-tuning. And then the model expects that because the original LLM is overwhelmingly trained on, let's say, one specific language, which is usually English, it should have better instruction solving or problem solving capabilities in that language. And therefore, if you want to actually solve the problem in Hindi, then you get the model to first translate it into English implicitly via instruction tuning, and then also get it to solve the problem in English and then generate it back into this thing. Now, this can be done by the translate test approach. Llama 2 really does well on the translate test paradigm. But implicitly incorporating translation might be a more seamless way of getting it done.
Nice. Swaroop, do you have anything to add?
Yeah, I think he already explained it.
Perfect. The translate test pipeline was nice on Llama 2. Yeah. Okay. I have another question, Swaroop. In what way do you foresee instruction tuning evolving, especially concerning adaptive learning in response to the evolving data landscapes? Two heavy questions. Yes. How do you see instruction tuning evolving over time?
Yeah, sure. So alignment is like a more broader term. Instruction tuning is still a big problem. Like how can I? So there are people have like various ways to generate say non-safe content. People have all these ways to attack a model and make it do what we don't want it to do. And now, so many of this is being handled. You can handle at prompting level, but clearly it has to come from the core modeling. When you instruction tune a model, you don't want the model to basically respond to bad instructions, right? Like, I mean, tomorrow you ask, tell me the credit card number of this person. If the model is perfectly instruction following, it should tell, right? But you don't want that, right? So the alignment problem is pretty much core to instruction tuning, and I think it should happen at training time, like how we encode and how do we train models. So I think those kind of thing, the safety issues as you grow, I think there is something big coming in that space.
Thank you so much. I have a follow-up question.
Just a time check. We have 2 minutes of left of Q&A session.
All right. So I have. I'll be quick. Two questions. One from Malay Joshi and other from Sambit. And is there any effect of lengths of sources and target sentences on training process of transformer-based models? This is possibly for Raj. Would you want to?
Yeah. So your model has to be trained on diverse lengths, on content of diverse lengths, so that it has the ability to understand how to handle different lengths. That being said, if the question is about whether the model can extrapolate to longer sentences, then yes, depending on what kind of positional encoding mechanism you use, there has been research that shows that if you train up to, let's say, 5 and 2 tokens with a good positional encoding mechanism, it can actually extrapolate to 2048, 51, 4096, and so on. And that's like a whole general area of work on long context LLMs, right? People have taken Llama 2 and made it work with 128K context windows. So yes, your model has to see a lot of diverse sources of different lengths for sure.
All right. So I just have one last question for Swaroop. Now, this is from Sushovan Jena. He says that I am from CV domain. So my question to Swaroop sir, being a researcher, how are people doing papers and bringing novelty in LLMs, as most of them are invented by others and we have scarcity of resources?
Like when you say scarcity of resources, you mean compute resources, or like what kind of resources?
I think he's talking about yes, okay, he's talking about scarcity of resources, compute resources. Yes.
It's a great question. I just give you a broad perspective of novelty do not always matter. I mean, if you, of course, if you are an academic researcher, you want to publish a paper, it matters. But at the end of the day, if you want to build a great product, want to make things work, right? So it's fine. I don't see that's actually sort of a transition I also went through after my PhD when I joined industry. It's fine to take a not so cool idea, but make things work and build a cool product. That way, the competitive landscape is increasing, and I would focus my energy there. And then instead of caring about novelty, of course, I mean, we all as a researcher care to be like great breakthroughs, but that happens once in a while. But yeah, I would not too much emphasize on novelty.
As Raj mentioned, the tenacity is key, and you know when to give up, but not give up at the earliest. That was all that we could manage. Thank you so much for your time, guys. I know it's quite late, quite early for some. So, that's everything. Thank you, everyone, for joining in and participating. Have a good time. Thank you, Raj. Thank you, Swaroop.
Thank you. Thank you for having me. Bye-bye.
Bye. Shanti sir, do you want to? This is lunch break for us.
Yeah, now I think we can announce for lunch break, and again we can meet after 1 hour.
Yes, so we meet at 1:20 so India time.
Yeah.
Same link, guys. Thank you so much. See you. Can we stop the recording?
Yeah, Devasis, can you stop the recording?